So we launched the first beta, I think it was December 31st, 2019 at 11 something p.m. because I decided that I would do it before the end of the year. And I think that was around 10 people originally. And we've since done a little bit more than 2 doublings of that. So we raised it to 20 around, I think, April or May. And then 40 more recently, like a month ago. And then we added some more people since then. And so we're up to about 50 something people who are on the beta list, who have access to the downloads and all that stuff. That doesn't mean there are 50 something actually active users, right? That beta membership comprises people who have a spectrum of different, amounts of time to spend using a new experimental programming language and so forth. Like some people, it seems like, are doing stuff nearly every day or several days a week, and other people are just like, oh, I poke around with it once in a while. And all that is, that's all intended, right? It's just to give people an idea of what the scope is. And so most of the time when we do communication, we have a little Discord channel where chat happens. I pop in there sometimes, but also I'm really busy sometimes, right? So I don't hang out in there regularly. When there are bugs and so forth, people email me at an email alias and I fix the bugs and respond. And that's a very productive way for responding to specific bugs, right? But what I wanted to do with this session was have some higher bandwidth communication that has the potential to be more about ideas, right? And maybe subtler things than, instant message or text kind of discussion can be. Yummy. So I thought I would start by just giving a very brief roadmap of what I plan to do with the next couple beta releases. And then we can roll from that into questions, discussion, and whatever people want to do. The very next beta is probably coming pretty soon. I would like to put one out Sunday simply because I'm traveling a little bit early next week. And that is likely to be Sunday, my time, tomorrow night. So like 36 hours from now. And that is likely to just be, bug fixes kind of beta. Some reports have come in. One or two of the reports are mildly scary. They're the sorts of things, most bug reports are small inconveniences, right? Like, oh, this error message isn't very good or whatever. But once in a while you get one that's like, this expression returns totally the wrong result during compile time execution. And you're like, oh, that's bad, right? We got to fix that one pretty soon. So that's the next beta, right? But then the beta after that, I would like to roll forward some more features, right? Because if you're just fixing bugs forever, things aren't moving forward. So one of the things that's been requested that I procrastinated on early on, simply because the projects people were making weren't really that big yet, was module features. More specifically, like what are the pragmatic aspects of how modules work, right? And so modules are this programming language's version of, well, they're sort of like header files that you would have in a standard library like C or C++, but they're also like libraries, right? Like precompiled libraries like you would have in C or C++ together, because we don't really have headers as a separate thing. And also because we try not to have that much in the way of precompiled binaries, because that adds complexity, and the presumed optimization that you get from that is not really meaningful when your compile times are actually as fast as they should be with modern computers. So the vision of the language for a long time has been that these modules would be a relatively decentralized thing. Because the model that happened in the C and C++ world sort of organically grew over a long time, I think, into what is the wrong model, right? Like back in the C days, in the earliest C days especially, like the headers were just sort of what you needed to interface with the operating system and or, you know, maybe do some user level stuff like strings and files and all that. But those were all things where, you know, depending on what system you were deploying on, the interface with the operating system may reach more or less into those varying things. Like there wasn't a lot in the very original C headers about like, this is just a high level library that we're providing to people, right? And so it made sense for those headers to be distributed with the compiler, you know, and installed on your machine globally, right? And C++ inherited that approach, but now C++ is providing tons and tons of high-level functionality that has nothing to do with your operating system and really doesn't need to change. But there are lots of, but they're still being deployed, you know, installed on your hard drive with the compiler, right? And there are lots of negatives about that, right? One, it means that compatibility has to be maintained because you need to be able to expect to download a program and compile it, right? And that puts a lot of constraints on what those libraries can be and how they can, and really how clean they can be and how understandable they can be. Because a lot of times, one of the major things you can do to make things more understandable is just to massively refactor it to work differently. And if you're just not allowed to do that ever, you get what we have today, right? In those languages. Another negative aspect is you don't really feel free to change things, right? Like the philosophy in C and C++ that sort of happened naturally as a result of this is that, you know, the file function fopen is not something that you could change if you wanted to, right? Maybe I want to change fopen, right? Like who are you to say that I can't change fopen? But it is just not a thing that is thought of because it's just annoying to try to do, right? You know, you get other things that crept more into the realm of more practical day-to-day problems, like, you know, using your own malloc is annoying and all these things, right? Okay. So that's one paradigm that I don't think is the right one. Of course, other programming languages have had another paradigm, which I also don't think is the right one, right? So like in JavaScript or whatever, every time you like compile or build or whatever, you know, it looks at all the dependencies and grabs them all and makes sure you're up to date with the newest one and whatever. That's also pathological in several ways. One way is, again, libraries are not really allowed to change very much. They have to be very careful because it's expected that your newer version just drops in and replaces the old version, right? And again, honestly, that is one of the worst things you can do with regard to code quality long-term is to fix things like that. And then especially like you have in the world of JavaScript and some of these other scripting languages, where you have very small granularity of imports, you not only fix these abstraction barriers with very defined semantics, but you fix them over like very small nuggets of code, right? So very little is really allowed to be done, apart from making a whole new, you know, library somewhere. But then you've got this proliferation of stuff that all does the same thing. And if you just want to know what to use, you don't really know, right? Like I think some choice is good, but you know, pathologically trivial choice is not good. Also, just with regard to reliability and with regard to, let's just say reliability, you know, I want to be able to pull my program out of the closet in 20 years and I want to be able to compile it, right? And I want it to work. A lot of the other features of this programming language are designed in that way. For example, the whole metaprogramming system, right? Like the program defines its own semantics. You don't need to rely on external tools being particular versions or whatever else, right? So, well, if you expect to pull down packages over a network onto a fresh machine in order to compile your program 20 years from now, you have no idea. Okay, so first of all, you have no idea if the internet 20 years from now looks like the internet of today, or if it's super balkanized or whatever, right? If you're in an emergency situation, you may not have internet and you may want to be able to compile things. Like there are many aspects of the way people are building some of these ecosystems that are, in my opinion, firstly, very unwise, but secondly, fragile, right? And so the goal is to be robust. And so the plan for the module system is to do what I think a couple of other languages have done, which is to say, look, if you're building a large application, what happens is the quote, what the kids call these days, the dependencies, just get pulled into your application, right? So you would have, a modules subfolder next to your build subfolder or whatever. And whereas the build subfolder just gets temporary files, right? Like, here's files for debugging and like object files and stuff. Your modules folder just gets whatever you import, right? And that has two effects. One is it's very robust because that code to open a file is like in your module subfolder, right? So it's going to be the same code to open a file 20 years from now. You can change it, right? You can modify it in your local copy and you don't affect the system copy. So that gives you a lot of agility with regard to just making things work the way that you want it to, that you don't have in other programming languages. Of course, then you have sort of the job of, how do you manage that change clerically? Like, how do you make sure you don't overwrite it with a new library and all that? But all that stuff is in your control, as opposed to the programming language or the operating system's control, right? The other thing it does is it just makes you aware of how much code you're using. And I think the number one problem with software today is you have all these people who are programming and they literally have no idea what code is ultimately used by their program, right? Whereas if all the code is right there, you can see what it is, which is great for learning and understanding your system, which I think we all need to do more of. But it's also good for making sure it's minimized, both the size of the system and the complexity of the system. You might look in there and say, what is this module? Why is it being used? Oh, it's being used because I'm outputting colors to the console and I use this thing that use this other thing to do that. Can that be done more simply, right? I think these are all good things in the long term. So, oh yeah, I could have made my face bigger while I was doing all this. Let me do that because there's nothing on the window yet. Ta-da. Okay, so that is going to be the first major feature addition, is just going to be better module handling. So there's a couple aspects to that. One aspect is just a simple one. Well, there's parts that have been figured out and parts that have not been figured out. So the parts that have been figured out are the ones I've been talking about. How does that work? Well, there's going to be, a module subfolder in your application folder, and you would control how that works with the build options, right? In the same way that your metaprogram can set build options normally. There'll be a subset of the build options that's about modules, and it'll say, hey, what's the name of your modules folder, right? And then there'll be an enum of what's the policy for modules, and you'll be able to pick between, like always use system headers only, which I'm not sure why you would ever do that, but that'll be one of them. Use system headers, but copy them into my local folder if they're newer, if the system headers are newer, right? Or use system headers, but copy them into my modules folder always, or just use my module folder and never use system headers, right? There'll be at least those four options. And so, I expect particular workflow for a large application would be something like, Oh, wait. And also import headers into my application only if I don't have any version of those, right? Which is probably going to be the default. So if you're writing a new program and you just want to import like, basic and, OpenGL and a few other things, then the default policy would copy those down the first time, but then probably not update them after that. That said, right, so one of the things you do when you're maintaining a large program is you want to explicitly say, okay, now is the time when I want to update my libraries, right? Because you don't want to do that all the time while you're developing a large program, because you've got real problems that you're trying to solve. You're like trying to build software, so you don't want stuff breaking all the time, right? But then once in a while, you're like, oh yeah, if I updated my font rendering to the newer version, I would get better layout for particular languages and stuff. It's time to do that. So let me check that off my to-do list and do that, right? And so basically, the ability would be there for you to tell your metaprogram to just maybe update a particular library, or honestly, it's probably a lot simpler to just do the file copy yourself, right? You go into your modules folder, you rename the old one to whatever .old and just copy the new one in, right? I actually would like to default to that kind of thing wherever possible, rather than having magical compiler stuff that just does copies and renames and things, because when there's a big complicated system of copies and renames and things, again, you need to understand that if you're going to do anything about it. And the tendency becomes for people not to understand and not to do it, right? Whereas if the policy is just, look, if you want to update a library, the simplest thing to do is go in and just move the thing over, right? That leads to people understanding. It leads to a certain kind of system transparency, right? And so we'll see exactly how that turns into. We'll see if if you don't run a metaprogram, right, are there going to be command line options to do some of this? Maybe, as the beta users know, there's a very minimal set of command line options right now. And whereas I'm not generally opposed to adding more, I am opposed to adding a lot more, because I don't want it to turn into something like a typical C compiler in that respect. Okay. Oh, and then another simple thing that people have been asking for is, how do I add more module paths, right? So right now, when you use a program, it pulls things from system libraries only. If you're writing a module, like people who are writing modules have this problem where, right now it wants to import them from the system folder, but their module isn't being deployed with the compiler, so they have to copy it there or whatever. And there's currently a single module path, but we'll probably make that more robust. And then the question is how does that interact with the other thing I was just saying about the policy of what to use when? And we'll see. I can imagine different ways of doing it. Okay, so that's the next big feature beta. I don't have an exact date on that, but hopefully it's not too long, because honestly, it's not that hard. It's just been something that I've been holding off on, while we did a bunch of other things. We only recently got struct literals that were any good. So, one thing at a time. Okay, so then the next big feature for after that is for the compiler to run a metaprogram by default, right? So right now, when you run the compiler on just a regular source file from the command line, you don't have a metaprogram running. What you have is the compiler just running a loop and looking for error messages and all that stuff, right? And that's good because it's maximally fast and maximally simple and all that. But large projects right now usually end up doing a metaprogram because they want to inspect their program and all that. And what the metaprogram looks like is a loop that, looks at what's happening in the build and decides how to respond to it and maybe adds or modifies the code, right? And one of the things that a metaprogram can do there is checking. And for example, one of the things you might want to check for is if you're doing a print function, you might want to check the format of the arguments, right? Definitely, I make mistakes in argument format sometime. It's a common thing for people to do. You edit your function call and don't change the things. Now, because I don't want to have a warning culture around the compiler, and what I mean by that is, if you use GCC or LLVM or something these days, in part because the original decisions made in C especially, well, in C in one way were unfortunate decisions, and then C++ just said, hold my beer, and made a ton of extremely more unfortunate decisions, right? You sort of need warnings in those languages to cover a lot of common mistakes that those languages encourage, right? So, what we've done is try to have better fundamental rules around when do implicit casts happen, for example, so that implicit casts are not error prone the way they are in C or C++. And so then you don't need warnings for those things. So we're trying to minimize the number of warnings that are in the compiler at all. There are a few, but the plan is that warnings mostly happen at user level. We could provide you a user level library that does certain kinds of warnings, but if you don't like those warnings, or if you like someone else's warnings from a module that they made, you could use that, right? But as a result of that, we do not check for those things at all by default right now. And that's actually a little bit hard probably for new beta users. There's a few other things. So, right now you say x colon equals something to declare a variable with type inference, and x equals something to assign a variable. And a common mistake is to have an if statement, and down in the block you accidentally say x colon equals to assign to the thing in the outer scope, but instead you're declaring a new thing that shadows the old thing, right? That is a thing that a warning checker could easily check for, but doesn't currently. Well, even the one that we give doesn't check for that right now. But even if it did, you wouldn't get that as a new user unless you went in and made a metaprogram and turned it on, right? So what I want to do for that build, and this is further out in the future, like maybe this will happen in 2020, maybe it'll happen in January, I don't know. But for that build, the plan is there will be a module called like default metaprogrammer or something, right? And that will be the thing that the compiler runs when you compile anything, right? And that will take a slight amount more time because it's probably going to bring in, some other modules or something. But on the scale of an application like the Sokoban game or something, it'll be very helpful. Actually, there's another thing to say about this, which is even on the big game that we're making in the studio, right? So we have a metaprogram that runs that checking, right? But our metaprogram doesn't have checking run on it, right? And so it's easier to make mistakes in the metaprogram than in the main program. And so, that would be nice. That would be addressed by this feature as well. And so there probably, because this is a thing that you wouldn't be able to help otherwise, there may be a command line option where you specify a different default metaprogram, or maybe you just start a different workspace with a different metaprogram. Like, I don't know. I don't know what our policy, maybe you just start a different workspace if you want a different metaprogram. We'll see. We'll have some discussion about that. But that's the background. And then when it comes to what I'm interested in hearing from the discussion, we'll see what the beta people say. I would be interested in knowing what are the most confusing things right now about how to, what is unclear, right? Sometimes things might be unclear because the fundamental semantics are confusing. There's a couple of cases of those, and those are cases when we could go simplify the rules of the language in some way, if we could figure out a smart way to do it. Sometimes things are unclear just because they're not documented very well. We have, so we have a set of how-tos that are an example-based guided tour through the language. But that is very incomplete right now. I think the way that it introduces things, I'm writing them, so of course I like it, but it's pretty nice sometimes, but it's also incomplete. And so, what should show up in the how-tos, what's confusing. And then aside from that, just, whatever the beta people want to talk about, right? I mean, the goal of this is to have higher density conversations. And so with that, I'm going to go to the questions channel. And whoa, there's a bunch of things. Okay. So should I start way at the top, or should I answer more topical things? This is when I need a moderator to pick questions, but I don't have one. Okay, let me just start at the top. And if I skip your question, the Discord people will know if I skip questions or not, because I'm going to run them in order. If I skip it, it may be because it's cramping the flow to talk about that right now or something, but you could raise it, you could just paste it again later to make sure I get to it or something. Okay, first question. You have a question about allocators. You can see that you could change the allocator on a context by changing an allocator and an allocation data. Let me make my camera smaller again so we could do code and stuff. You don't need to see me real big like that. I'm not a giant named Kanye. Okay, so, oh, not here. There. Here we go. So the question is about allocators, which live on this thing called context base, which you can see in modules preload. Preload this is actually an interesting question about how to structure the compiler. Is just, there's a couple of modules that are not optional, like the compiler requires them to run. Preload is one of these, and they're not really going to be subject to the same like module policy that I was just talking about. I think they need to be separated out into like internal compiler internal code. But anyway, this context-based thing is the context that you get when your program first starts up, unless you modify it. And the question is about allocators. For allocators that allow individual allocations returned, how do you specify the equivalent of free to the context, or don't you? Okay, so an allocator is, it's not a function like alloc, right? It's a really relatively more complicated function. Let's look for default allocator. Here we go. It's got a bunch of arguments, and it's got this thing called allocator mode. And what this is this is enough arguments to do malloc free and realloc and free the entire arena and add tracking to this particular allocation that you just made and whatever else, right? And so the modes that are supported right now are actually just allocate, resize, and free. I think we used to have free all there, but we don't have it right now. Maybe that's because the preference is just to call a function on the actual data structure containing the memory. But the point is, you could extend this with values of your own. You just kind of cast them to shoehorn them in there if you want your allocator to do more things, right? And so that allocator mode determines how these are interpreted, right? So for allocate, the size is given. For free, for some allocators, you may need the size, but our standard free doesn't take a size argument, the free and basic, but you could make your own that does and then calls this with a size. Old size, new size if you're resizing, old memory pointer if you're resizing, otherwise ignored, or actually if you're freeing, right? And then the allocator data, which is just whatever accounting data that allocator may need in order to do its work. So what you do is just write one of these, and then other functions will call them. So for example, okay, so in C or C++, if you call the malloc function, you're getting a very specific allocator, right? And if you want your own allocator, either you have to call a different function, which would then imply changing all the source code, which is annoying, right? You could define malloc to be something else, but then if you're linking libraries and stuff, that doesn't work, right? Or you could intercede at the link level, which sometimes has unexpected consequences, right? So what we do is instead, if you go into modules basic, you'll see like alloc, which is our basic allocator. And what this is basically just a wrapper around that allocator type, right? let me actually do, I like spaces these days. It's a wrapper around that allocator type where we say, okay, we're calling it with allocate and the size. We're just marshaling the arguments in the right way. Okay. So this doesn't really do very much except serve as the standard rendezvous points for everybody. So if your program calls alloc, that's fine because you can substitute which allocator is being used without actually editing that procedure call, right? If you want to use a module that's calling basic.alloc, that's fine, right? That actually does not have a bearing on what is the actual allocator that is used, right? So that's the design of it. Hopefully that answers the question, right? Basically, you give the context the thing that does alloc and free and realloc, right? And whatever else that you want. And these functions are just call into that thing that you provided in different ways, right? How to configure the compiler to build a library for use on Android ARM64. We are not doing that yet. That is not supported yet, simply because of lack of programmer hours to devote to ensuring that these things stay maintained. Someone on the team did successfully target an ARM64 platform before, and it wasn't actually that hard. It might actually still work if you provide the right LLVM target triple in build options, but it is not officially supported right now. For things like that, also another thing people have been requesting is a Mac build. We have a few people at least who are using Macs, but using the Linux build of the compiler in a VM because we are distributing the Linux build and the Windows build currently. We could, of course, expand to a Mac build. I do think, so we haven't tested or shipped Mac in a little while. So although ostensibly the compiler runs on Mac OS right now, it probably doesn't in reality. Probably something's broken, right? And so I think the goal there is to hire some people, one of whom one of whom can have as one of the parts of their job just making sure that that kind of stuff stays working. It's just, actually with the company in general, we've had on our list for a while that we need to hire a few people. But COVID has made all this really weird. And honestly, also, I've kind of been enjoying just being able to sit down and work on this kind of stuff in relative isolation. But it would be really helpful to have people on something like that because that would allow us to expand platforms. So especially, right, so one special reason we're not distributing Mac right now is because of the new Macs and the new Mac OS, right? That gives us even more of a hassle of different things to support if we claim we're supporting Macs right now, right? On the other hand, if we had someone who was doing that, that would be helpful, right? And we could do it. So it's on the list, but right this second, it's not supported. What made me shrink the compiler team back to just myself? So like, there's a lot of things here that I shouldn't talk about because they're company internal matters. It wasn't the plan to shrink it entirely back to myself, but some things happened that were surprises. But apart from that, okay, the whole reason the whole reason this programming language is being done, as you could see if you go back to my original videos about it back in 2014, is that I feel like, well, and this is actually something that probably has been explained better in subsequent videos actually, because thinking about this and meditating on it over the years, I just formed a clearer picture of it. But it's just, the reason why I'm doing this is because I detect that there's some things being done in programming language design broadly that I don't think are the right way to go, and where most new efforts are going. And so if a language like this doesn't go into a different territory, maybe nobody will for a while, right? Or ever. So the goal here is really to question assumptions and do things differently and try to keep things simple and try to keep things straightforward. And we sort of had a problem, a team dynamic problem that was my fault, surely, with the previous time that we tried to scale up the compiler team, which was just that I was like, oh man, I'm very busy all the time. I want to spend most of my time doing work and getting the compiler nailed down. And I sort of took for granted that the rest of the team was like really on the same page with regard to understanding what this language was trying to be, right? And that really wasn't true. And that didn't become clear to me until much later on, right? Like I sort of figured that like, hey, I do enough speeches and live streams and whatever that people ought to know. But that's also sort of one of my personality flaws is I think that things are obvious or that people know things. Or I also felt like, hey, from looking at the source code, the philosophy of this ought to be clear. And it really wasn't, right? And that probably was me not communicating well enough. It probably was me not, expecting people to understand things that maybe they shouldn't be expected to understand, and so forth, right? But what that resulted in, right? The result was I was unhappy all the time because people were changing the compilers and the related tools in ways that I didn't like. And the problem is I can only go so fast. So if my job is to keep this on the rails and be the thing that it's trying to be, if it's diverging from those rails faster than I can keep it on the rails, that jeopardizes the whole project, right? It's like, wait, what is happening here, right? What are we even doing? And I felt like that was happening like a lot of the time, which is one reason why I haven't been so fast to re-enlarge the team is just like, oh man, I'm much happier now working on this than I was like 18 months ago. So what else can I say about that? There's another weird thing, and I only again became aware that this was a problem like after it was a pretty big issue. And it's just like the internet has a lot of programming language efforts on it, right? And people who program have obviously grown up in environments where they use a lot of programming languages, or at least a few. That's how you learn. And human beings learn by example, right? And so maybe in the absence of a large amount of direct team communication from me, people would fill in with the example that they know, which is all the other languages on the internet, right? And so what I think people will naturally do is if they work on something, they'll make it like what they know, or like the things that they like about what they know, right? But again, this is not trying to be that. It's trying to be a different thing. And so, yeah, when we scale up the compiler team again, that is going to be forefront in my mind is like, how do we do this without it going off the rails, right? And without it, like part of the mission statement is not to be big and complicated, like something like C++, or have way too much code, right? Or to not be overly complicated with, building layers on layers and layers of things that are all supposed to be simple, but that in reality make a complex maze that nobody ever gets through, right? And there's also an internal problem, right? Which is if you claim that this is the philosophy, your code internally has to work that way too, or you're being fake, right? And if you try too hard, too fast to just like jam out code and it's not good architecturally, right? And it's not exemplary. Like if I couldn't show this to people and say, this is a proud example of how this programming language works, then you're kind of faking it till you make it, which again is what most people do on the internet, but is not what I want this project to be. And so I was at a very deep level not comfortable with where this was going to go, especially if we continued to scale up the compiler team. So yeah, I mean, that's where it's at. So I always have these choices of like, how am I going to approach this? Like, we could hire a 5-person compiler team right now to make things go fast, but I think that would be kind of a disaster in terms of the mission of the system. I would not be able to keep up with that enough to keep it on the rails. And so figuring out how to solve these problems is one of my major concerns going into 2021, I would say. The other thing that happens is, we get a lot of offers from people randomly to just help out with things. And sometimes we can accommodate that, and sometimes it's not such a good idea, right? So like when it comes to fixing stuff internally to the compiler, that's probably not a good idea. When it comes to, contributing modules and stuff, we already have people who are doing that. But like I said, the goal of the module system, well, I didn't actually say this part of it, but the goal of the module system is to be decentralized pretty soon. And so after this beta goes out, with modules being different, being handled differently, I think it'll be easier for people to exchange their module code. And also though, it leaves the door open for people to make metaprograms that like automatically download modules from a server or something. I don't know if I want to culturally encourage that, but it could be a thing, right? I'm really not sure. That definitely wouldn't be built into the compiler, but is that a standard library that we distribute eventually? Maybe. There is a lot of power to being able to automatically pull modules off the internet, but it's also demonstrably a very bad thing in many modern programming languages. So that would have to be figured out. But the plan there is, the plan or the goal, one of the goals of a programming language author should be to set up something good and then get out of the way of the users, right? So I don't want to be preventing people from doing good things or sharing those good things with each other, right? The question then just becomes, in the cases where some of those good things would be internal to the compiler or the very core libraries, right? What does that mean? And is there a way that we can accommodate more help? And I'm not sure. At the very least, that would have to wait until we add another person to the compiler team whose job might be to vet that kind of contribution. We'll see. How am I feeling about how the beta is progressing? Do I have an idea how many more times I want to expand the closed beta, or roughly when it might go into open? Well, it definitely should not go into open before the features that I mentioned are done. It also should not go into open while it should not go into open until certain classes of bugs like stop being reported, right? So even after features are new, because it's a complicated language where everything interacts with everything else, sometimes there's bugs with things, especially because we do compile time execution and because, we pack our own object files and stuff. So for example, with struct and array literals, for a while after they were added, there were still like weird bugs with them in certain contexts and stuff, right? And so you don't want to go to open beta while that kind of a thing is still hanging out, right? But once we've got a certain set of these features in, once the kind of bug reports that we're getting are I don't know how to put it, but just once that kind of thing isn't getting reported anymore, then we would do open. I'm not sure when that is. That also probably requires at least somebody else on the compiler team to manage that open beta, because I don't want my time on the compiler to become totally, managing the open beta, which is just kind of what happens when there's a lot of people, if you want to be responsive to the people and all that. So I don't have a specific time frame with that. It'll just be more like when we feel comfortable with it. We have done 2 doublings of the beta size this year, more than 2, right? Which 2 doublings a year is a very high interest rate, right? If you had your money in the bank and it was doing 2 doublings a year, you'd probably be very happy with that. So that de facto becomes an open beta eventually anyway. In fact, even if we keep the beta closed for a while, we're going to have to change the way the invites work, because I don't want to have to personally manage invites. So we might do something like Gmail did way back or whatever, where we give existing beta members invite codes that they can give out to people who they think would be good beta members or whatever, right? We just haven't done that yet. But that's probably the plan before the open beta, is go to something where there's invite codes for people. I prefer you to report bugs ASAP or wait and bundle up a few at a time? I would say it depends on the nature of the bug. If it's a bug like, hey, this error message wasn't very clear or whatever, it might be nice to have those bundled up. Although actually, no, you know what? I changed my mind. Because the thing is, if I get the emails one at a time, with one bug in each email, it's actually easier for me to handle them, because I can just check off that email as done when the bug's fixed, right? Whereas if it's 3 in there and 2 are easy to fix and 1 is harder to fix and needs to wait on some other functionality, that's like, at some point, at some point using email as a project management system is not a good idea. But right now it's the simplest, least overhead thing to do. And so I'd prefer to keep doing that. So actually I would say 1 at a time, honestly. So someone says, I like the monorepo project approach for modularity. Does it conflict with your earlier statement that compilers' languages are underspecified? Should metaprogramming fill all those gaps? I am not sure I understand the question, right? So what I mean by a language being underspecified is, for example, if you have a bunch of C files in a folder, that does not constitute a C program, because you also need a definition of what the files are to compile, right? Which isn't all of them, because some of them will not compile on their own, right? And some of them might be for other operating systems and whatever, right? And so now you need this thing called a make file, but then make is not a very good programming language. So now you need this other thing called super make, and then you need super duper ultra make on top of that. And so you end up needing like several programming languages just to do your programming language. And then you go to another operating system where those aren't all present or not all work the same and whatever, right? And so what I mean by the program being specified is, ideally, all you should need to compile the program is the program and the compiler, right? Anything more than that, and you're kind of on thin ice, right? In addition to just having hassles as you move around to different operating systems, right? So there's 2 things. There's reducing hassle today, and there's ensuring that in the future your program still compiles, right? So that's what I mean there. And so from that standpoint, you know, downloading all your modules off the internet every time you compile, for example, means the program's underspecified because all these things that you use are not present, right? And if they become missing someday, you have giant question marks in your program, right? Whereas if they're included in the program, then the program is specified. I feel like, though, there's some part of that question that I don't understand and I'm not answering. So if you want to expand and clarify on it, that would be good. Okay, why not closures? What are the alternatives to closures? What can we do in the language that is equivalent to what closures provide? Okay, so early on in the design, I assumed that I was going to add closures relatively soon, and I just have never done it because honestly, it has not been that important for what I do. I understand that some people like them. I did computer science at University of California, Berkeley, where they teach how awesome closures are in the very first class. Since then, though, I got cult deprogrammed, and I don't actually think they're awesome. For many reasons, not least of which is efficiency of your program, right? For the same reasons that I talk about sometimes in lectures, also in the how-tos for the language about paradigms like object-oriented programming, or even just things like the fact that you should use smart pointers for memory allocation, the same way that those things insidiously make your program very slow and hard to understand in ways that you don't expect, closures do the same things. Because a closure is like, look, this is an instantiated thing with certain particular data that has its own lifetime separate from other data. And you honestly don't really want to do that if you can help it. It's not, it imposes a lot of costs that people don't necessarily think about. Now, that said, it is still in the roadmap probably to provide closures at some point. There are practical implementation questions of how do we provide all the flexibility that you have in the language with regard to allocators and that sort of thing, without making closures too much of a hassle. Also, how do you avoid the big annoying thing that like C++ did, right? So in C++, a closure is essentially, you know, a functor, which is essentially a struct with an overloaded paren operator, but that means it's not actually a function type. So anytime that you want a negative function or a closure, you need a special thing. And actually, of course, because C++, like a member function is also a different type, right? So like C-style function, member function, and closure are all totally different things actually, right? And then you need to paper over that at user level. How do you avoid that? Well, I think the way to avoid it is by having all the standard function type in the language be a fat pointer, right? Where every function has a data pointer that it could refer to, right? Because, for example, when we're talking about allocators, right? You have allocator and allocator data all the time, and you need to pass those, right? Why is that? Well, you might have a lot of different heaps, right? And the allocator might be the heap handling function, which might be the same for all those heaps, but the allocator data might be the pointer to the base of the heap, which is different for all those heaps, right? So even without closures, very often you want to have a data pointer for functions. This is also true just with thread safety generally, right? So like qsort in C was like, hey, here's the type for the sort function that you pass to qsort. It takes 2 arguments and not really that much else, right? And so historically in C, if you wanted to do qsort and you needed more data, you would just put the stuff into the global data. You'd make some global variables that function reads, and put the values in there, and then run qsort on those, and it would do the thing, right? But that's very bad for thread safety, right? So now maybe you put those in thread local storage, but that has performance penalties, and also it's error prone and all these things, right? And so it's just kind of a good idea to have a data pointer with a function pointer, right? So that is probably what will happen. Of course, you still need to specify sometimes. If you want to have a function pointer that you pass into C, you have to specify that it's actually just the bare code pointer with no data pointer and so forth, right? So that's been the vague plan for a long time. It's just that some of these other things seem more important, right? Like the module features I discussed before seem a lot more important to me than adding closures. And so that is what that is. But I would expect that, okay, I would expect that first having data pointers be part of the function pointer type would happen. And then you could explicitly set those. The same way a string has like, .data and .count, probably a function does too. And it's probably, .code and .data or something, right? And then after that, so first we would implement that, see what all the ramifications are, deal with that, and then implement closures on top of that. And then the nice thing about that is once that's done, you can have all kinds of stuff, right? Like you don't have the C++ problem of a functor and a native function type being a totally different thing. They're like the same thing, right? So you don't need to make a mess everywhere like you do in C++. I'm not getting through the questions very fast, but you know what? I'm just going to go through the questions in order. And if everybody gets tired and leaves and we go way too long, we can just do another one next week or in a couple weeks. We'll see. I didn't preset a prescribed length for this session. So we'll just see how long it goes. And yeah. Okay. You often talk about how syntax is not definite right now. Is there anything that you are seriously considering changing in the future? Looking at you, AutoCast. Yeah, AutoCast maybe. It is weird. The dereferencing pointers is a little bit weird. That said, I'm thinking about looking at a little bit more implicit casting. I'm looking at adding an implicit pointer dereference. So if you have a pointer to something and you're calling a function that takes that thing by value, you're implicitly dereferencing that, which might sound scary because it's like, oh, I might get a null dereference in a weird place that's hard to debug. But in a debug build, you can have a compile time check for that, just like an array bounds check. And so it would be very easy to isolate where that went wrong, right? So that would result in writing dereferences explicitly less often. But yeah, like changing the dereference. But honestly, I'm not thinking that hard about that stuff yet because I really do want to do a question everything kind of syntax approach a little later on. When, like once things go in, maybe before open beta, right? Because you want to, you don't want everyone in open beta to have to like do a big syntax adaptation. But, look, we're questioning everything. We're questioning every operator, the way declarations happen, all that stuff, and just seeing, some of the syntax I think works out very well and is unlikely to change, but some of it, some of it, there are clear downsides to. So for example, the colon equals versus equals thing is an easy to make mistake. Like I've said, it's also an easy to catch mistake, hopefully. But until we actually implement that checking and see how often that mistake is caught, that assertion that it's an easy to catch mistake is untested, right? And so there might be something still not easy to catch about that, which might lean more strongly on, oh, we should change that, right? So that's the story about syntax changes. As with standard modules, could there be standard metaprogram modules which could be included to enhance build processes, for instance, to impose common house rules? Yes. And so, okay. So you already could have that right now. In fact, modules/check is one of these. So if I go there, you can just call this function. It's not documented right now, but you can call this function do error checking on a compiler message, right? And it does some stuff, right? It does 200 lines worth of stuff, including printf checking. So like printf and scanf like functions. Is that all that it does right now? That's all that it does right now. But you could add other standard checking in here, right? Or add more modules or something, right? Now, the thing that this doesn't do, this is just a function that you call, right? What if this requires some setup, right? What if it requires some shutdown, right? I don't know. And so there's a question of should we make more of a convention for that? And well, I think the answer to that is I should make it possible so that there's more of a convention, and I should maybe make one that you could start with, but I don't want to constrain that either. Like if people decide that they have a better way to organize these, right? And so if we put up like the standard metaprogram, like I was saying at the beginning, the question is, would things be pluggable into that? Like, okay, that's another question is, can these read command line arguments, right? I mean, they could already just of their own volition look at the command line because you have a call to like get that. But is that a good idea? Like, does the main program want to filter out arguments meant for one thing versus another thing? I don't know. All this really, I think, is to be figured out, what that structure could look like. The question of what is standard library versus external stuff keeps coming up. How am I aiming to delineate it? Would a batteries included approach covering most of the everyday stuff not provide a reasonable amount of value? Relatedly, basic is a bad name for a module. It's fairly arbitrary, different. Yes. Okay. So what basic means to me, or what it meant to me when I made that name, is just like, here's a bunch of stuff that many programs will want to call if they're not trying to be absolutely minimal about what they use, right? It's meant to be just like an easy to get started module, but it also doesn't include the kitchen sink. Like it doesn't include graphics, for example, because graphics is just giant and you might want to use different graphics and all that, right? So I agree that the name is not very suggestive and it should get renamed. As for what's standard library versus external stuff. So what gets distributed with the compiler already, I would say, falls into both of those categories, right? Some of it is like really like stuff like basic is like, look, this really should come with the compiler. Of course, if you want to use somebody else's version of it, that is totally fine. And the compiler would by no means enforce you using the one that comes with the compiler. But if you just have the compiler on your machine and want to get started, you should be able to use that, right? Other stuff like the Vulkan module and whatever, I don't know. I mean, if it became standard to download things off the internet, maybe that would no longer come with the compiler, right? That line of delineation has yet to be drawn. But it's sort of a fractal question. Like, what does the compiler include when you download it versus what does a module like BASIC include? Should BASIC include more stuff? Should it include regular expressions? I don't know. In part, I think that depends on code size. In part, I think that depends on... I forgot something. There's another feature that I want to do soon. So, you know, right, one of the reasons I wanted to keep modules small in the beginning is again, because you shouldn't have to understand a mass of things if you want to understand a simple program. And one problem that modern software has is dependencies just going out of control, right? But then a second thing is Well, just raw compilation speed, right? Like if the philosophy of this language is that you compile things every time in order to avoid all these problems that happen with incremental builds and pre-stored compiled binaries and all that, then having a convention where you're compiling way more stuff or encouraging that culturally doesn't seem like a good idea. That said, it's occurred to me that, the internals of the compiler have gone through many revisions in the past years, right? And where they are now, it actually would not be very hard. I think I could do it in a day and have it work where it only compiles things that are actually being used, right? It would have to parse everything, but parsing is really fast. It's the type checking and code generation that take longer. And so, from that standpoint, it might be okay to let a module like basic be a lot bigger because it wouldn't actually be adding that much to people's compile time to add all this code that they're actually not using, right? Yeah. Someone says, are there plans to add built-in support for code hot loading for the running executable? Early on, I thought that I would. Now I don't know, just because, like right now, I would rather focus on reliability of the system. And the thing about code hot loading is you start again getting more into like operating system details and weird things that could go wrong. And then it's also a workflow that can go wrong, right? Because if you change a data structure and you forget that you did that and your program crashes when you hot loaded, it just reduces the morale of what's going on, right? So in my own games, I don't set that kind of thing up ever, right? That said, so maybe if that doesn't go as a compiler feature in the near future, it may be something that people already can do. So like Casey does that on Handmade Hero just in C, right? With a metaprogram here, it actually ought to be pretty easy. So if somebody wanted to do a code hot loading metaprogram, other people might appreciate that. And I think that it probably is not hard to do right now. And if it is hard to do, then it's my job to make it not hard to do. That's where I think that would land. Someone says, I have a big change for the built-in hotloader module that fixes its totally broken Linux part. Yeah, it's not tested on Linux at all, by the way. That's another thing that happened when there were more people on the team is just, again, contrary to what I would recommend, because I wasn't keeping a very tight watch over things, a lot of code got checked into modules that is ostensibly ports of things to different operating systems that like never got run or never got tested. So there's like functions, there's like API bindings that are missing arguments sometimes and whatever. And it's like, that should never happen, right? If you're going to check in something that is ostensibly for other people to use, you should use it first 100% of the time, right? And so again, the fact that has happened is on me, right? And there's a lot of module code, so it's not easy for me to snap my fingers and clean that up. But on the other hand, you can see why that's a reason why I don't want to like accelerate throwing a bunch more module code in, right? Is like, look, no, we need to actually use all of it or cut it, right? Just don't like have all this stuff there, right? And so hotloader probably shouldn't claim that it has a Linux port. But these fixes need to change the API slightly. Do you want such bigger changes for built-in modules? What I would say is, like at some point, we need to throw the switch where, as opposed to trying to be a central coordination place where we integrate everybody's changes, like that's always a bottleneck, right? I could make a game programming analogy, but maybe I won't. I'll just say, even if we establish a process for submitting all these, changes to modules and changes to the APIs of different things that then go into the distribution with the compiler, that process itself is going to be a bottleneck, and there's going to be an opportunity cost with it that subtracts from core development, right? So what I would rather do is transition more quickly to an environment where it doesn't matter, like where people can realize that these core compiler modules that are distributed are not authoritative, and that you could change them and you can distribute them to people, and your version could be known as the better version for a long time. Because, what I would rather do, here's the thing. Like what happens with code all the time is you start somewhere, you see some ways to make it better. You see small ways and then maybe big ways. And for the version that ships with the compiler to track this whole evolutionary process is maybe not necessary, right? Like what maybe the better way to integrate changes is to just let people make their versions of hotloader or whatever, let those evolve for a little bit, see what's really good and what's really robust and what really works in the widest number of circumstances for the most people, and then incorporate that into the, not even the standard, because there's not a standard library, but just maybe have that be the one that we ship by default, right? This actually brings up another question though. And this is a question that is not completely sorted out, all right? And it is the following. And I think it's actually very important. If I'd realized we were going to talk about this, I would have brought it up earlier. One of the many problems with modern software is the idea I drank my tea and it had a lot of tea dust at the bottom and it got in my throat really weird. So I may be taking a few gulps of other liquid now. There's this idea that comes in a couple different forms, but the basic gist of it is that your code, or code that is good, should be as general as possible and should handle as many situations as possible. But do you know what that also means? That also means that code has to be as big as possible and as complicated as possible. I mean, that's a little bit of a sarcastic way of saying it, but that's what it means, right? Like having code that is small and specific and handles one very particular use case means that code could be very simple, right? And so what happens in libraries all the time is as requests come in from different users, those different users all have different use cases, right? And well, if the policy is we adapt this to all our users' use cases, which sounds good because the whole reason we make this language is because we want the users to have a good time using it, right? That sounds good, but what that results in is code in the end that spends most of its time and most of its text doing things that most users of the code don't want, right? And so is that a good idea? I would say it's not a good idea if that's the only thing you ever do, right? And that's another reason why I don't want to establish this process where we incorporate changes from everyone, because it means that by default, you're following that philosophy, right? And so maybe what I would rather do is say, hey, here's the hotloader that we use in our game that does the very specific thing we need for our game, right? And by the way, it doesn't support Raspberry Pi or whatever, right? And then maybe there's the more general one that's like, if you don't know very specifically what you're doing and you don't care about efficiency and whatever, you could use this one. And this is the one that, like, you could have, it's like having a small, sporty airplane and also a big bulky cargo plane, right? And having both of those is valuable, but having the philosophy that all our modules should be big bulky cargo planes, I think is deeply incorrect. And it's what I see most places doing, and I don't want to do that, right? So those are my concerns around that topic generally. All right, we're up to an hour ago in the questions. So, oh my God, we may have to break this into another session. We'll see how long my voice holds out. I mentioned that struct literals are new, which explains some of the issue, but what are my current thoughts on allowing non-constant values for struct literals? My thought on that is we ought to be able to make a macro for that, or a function. It might not be very easy to write that macro or function given the current macro system. And so that is actually another thing that I want to do feature-wise. Like, I think the current macro system is kind of powerful, but it's not as powerful as it should be because it's just hard to do certain classes of things. And that one or two relatively small compiler features might make it a lot easier to do these powerful things, right? I'm not that worried about making language syntax for struct literals with dynamic values, although we could. Like, that's an option that we have. It could be all right, let me lay out what the choices are, right? So one choice is there could be a struct literal syntax that's universal for either struct literals that are static at compile time or that have some dynamic elements, right, that need to be computed at runtime. And you can't necessarily tell which it is by looking at it. I mean, you sort of could, because if you see a function call in there, you know what that is. But like if you see an identifier, you might not know unless your IDE is telling you, or if you have a very strong capitalization philosophy, whether that identifier is a constant or not, right? So the idea that the compiler should make it one thing or the other, depending on whether it can, is a little bit against the philosophy that I'm trying to go for, because there's some surprise there, right? Like, you as a programmer maybe don't have an absolutely clear idea what the representation of this thing is in terms of memory and computation. And that's not really the way that I want to go. That being said, right, because you have the ability to have your metaprogram look over your program and report what happened, like whether that became a literal or whether it became like, you know, a dynamic initialization, you would be able to see that. And so maybe it's not as invisible as it would be in other programming languages, and maybe that makes it less bad to do that. So this is the kind of thing that I'm still working out, right? When it comes to initial design decisions for this language, they're based on the experience that I have in C and C++, which put together is almost 30 years of experience by now, right? Like, I have a lot of opinions about things. When it comes to this language itself, I don't know, right? I've only been using it for several years. I don't have that much experience in it, and it's been changing over time, right? And so some of these decisions, I don't know the right answer yet. And in those cases, I prefer to just see how it works out for a while. So I think what I would do is just, we leave the current struct literals as literals only, right? No dynamic initialization there. We can make a macro or something for dynamic initialization, and then just sort of see how much of a pain in the butt is the macro. Does everybody hate it? Would it be better if it was built into the compiler? Is there some disadvantage that I don't see to doing it that way, and so forth, right? And then just go from there, right? You couldn't find classic C-style for loops anywhere in the docs. There aren't. The while loop, you have the while loop, and then you have the for loop that is in there. I don't think that I have a plan to do that. Again, that is something that you could make a macro, though. You could make a for macro that lets you put those things. I think. Again, there might be like weird inconveniences that would make it really annoying. And so, we just have to look at that. But that would be my preference in the short term. Have I thought at all about array programming? No, I mean, so the question is like, assigning an array to all, like assigning a constant to all members of an array and stuff. That's just not what kind of programming language this is right now. Like sometimes when you think about stuff like that, it would be neat. Like those are neat features, but they're just not the kind of thing that we're focusing on at this time. Currently, a for loop over an explicit range disallows use of it index. Would you consider allowing this in the future? This would reduce friction when, upon code and maintenance, the explicit range is replaced with an array whose index needs to be tracked. Maybe, like, I've definitely had myself found that to be weird once or twice. The origin of that is just that when I was writing the code for for loops, I was like, yeah, there's only one thing in this case, and that's the iterator. And in the array case, the iterator is a different thing. So what would be the solution? Would it be for it and it index to just be the same thing in that case? They would be aliases or something. You could send an email to the mail alias and let me know what you think. Could you get a sockets or networking module? Seems like it should be in standard library. I mean, probably. It's just we haven't had the need to do one for our own internal use because we're making a single player game right now. And so, that's how things are happening sometimes. But I agree that it would be good to distribute one with the compiler. Currently, the single underscore can be used as a variable like in C. Do you intend for this behavior to endure, or are there plans to change it to function as a blank identifier like in Go? It is quite possible that we would make that the blank identifier, if enough people want that. I've definitely found cases where I want to use junk values, right? There's a few questions to answer, like if you return that, what do you get? Do you get uninitialized or do you get a default value of the type? I guess the answer would be you get a default value of the type because you could say triple dash for uninitialized, even though we don't do that right now. You probably could. Anyway, that would be another thing. You could email your suggestion about what you think is the right way to do it. Are minor contributions to the existing documentation like typo fixes and small content additions welcome? Absolutely. Typo fixes for sure. Content additions, I need to exercise my editorial judgment over whether that's the right way for the discussion to go or the right way to explain things, but possibly. But also, a few people have written their own primers and guides to the language. And if you really want to contribute in that way, that might be a thing to do. And again, I prefer the decentralized approach to that. Like if what we're talking about is what goes in the how-tos distributed with the compiler, then I'm going to be really picky about that, right? If it's just something that you are writing that you want to give to people and it becomes really popular and a lot of people use it, right? Of course, I have nothing to say about that, right? That's your thing and it is what it is. So, yeah. I'm going to have a little more chocolate to try to coat my voice. I've been talking for 90 minutes. To align a big team on a project, it proved useful to restrict certain features of the language. You understand that you should write a metaprogram to fail on features you want to restrict. Yes. That is the recommended way to do it. There are definitely some metaprogram examples in the examples folder. They're not minimal right now. I think one idea for a new how-to that could happen soon is just, here's how a metaprogram works. Like, here's the most basic metaprogram that like does the loop, but doesn't do anything. And here's where you would do certain things, right? And then that also could refer you to the default metaprogram to look at one that actually does something when that default metaprogram exists. Patrick had a question a couple days ago about trying to modify parameters to functions in a function like external libraries. That's part of the calling convention. That is clarified in the how-tos now. I think so. It wasn't back when you got on the beta. Let me see. Yeah, I think it's in here. You know, maybe it's not in here. Hold on. I remember documenting this recently. Let's see. There we go. 250 how parameters are passed. Okay. So this file talks about why you, for example, cannot modify struct parameters to a function right now. Now, it is possible for the compiler to, if you decide to do that, to generate a copy of the parameter, right? So that you could do just like you would in C. I'm not sure if that's a good idea. Again, I would be interested in hearing people's opinions about it. Whether you would like an invisible copy to be made in those cases. Like, it's a weird thing, right? So some languages, newer programming languages, are all about immutability, right? And this language is not necessarily about immutability, but I sort of felt like, hey, we sort of have this natural experiment where, due to the calling convention, we can think about immutability of parameters. So let's just see how that goes. And so we're in the middle of that natural experiment, right? That's all. Something slightly confusing is dependencies between metaprograms. When two metaprograms share a common namespace that they might both want to change, you might get a dependency that doesn't really exist. When two metaprograms share common namespace that they might both want to change. Do you mean, okay, see, there's so many questions. Hopefully I can get to the update. Do you mean like one metaprogram that's running like from the outside of the program and that's calling out to like different submodules? Or do you mean like the program internally to itself that has a bunch of run directives that are all like firing off at different times? Or do you mean, you know, the interaction across between those? Or do you mean the current inconvenience that's on the to-do list where like run directives can cause a circular dependency error because they're waiting on each other to insert names? That latter one, if it's that one, my plan is to do something to fix that really soon. I don't know what that thing is, but it's important to fix. Like the pain in the butt thing that you have to do right now, where you have to like write a lambda inline to the thing, is it's annoying, right? And it makes programs harder to read. So you shouldn't have to do that. You do have to currently, I'm looking forward to fixing that. We had a fix for that. Like earlier, in earlier betas, you didn't have to do that. but that introduced some other behavior that was a little bit inconsistent sometimes. So the goal for me is to come up with some system that permits that without without it being a hassle for the user. Yeah. Is there any long-term plans about documentation in terms of format and scope? You really like the current how-tos, but imagine there is a large amount of work to do with documenting the distributed modules and language features. Maybe more people could help with that. Yeah, I mean, that's a question. Like, so right now, okay, because it's me doing all this stuff, right? There's good things about that and there are bad things about it, right? The bad thing about it that we've already, touched on a few times is just that I'm very bandwidth limited in what I could do, right? But the good thing about it is quality is high. If we transition to like stuff like, hey, there's a wiki and people on the beta are contributors to the wiki and they could write documentation and stuff. That is good in that things can happen sooner, but it's not necessarily good in that those explanations are likely to be missing certain kinds of things. Like, for example, which one is the memory one? That one. No, not the executable, Emacs. I don't recommend you read the executable. So this one, like, is really about, it explains the language semantics in terms of a very broad set of ideas that like nobody else was going to sit down and write but me, right? And so you get a different kind of documentation. And so the question is, where does the line get drawn there? And or should I have anything to say about that, right? Like maybe there's just a wiki and again, it's decentralized authority and other people are authoritative over that and that's fine, right? And then, somebody else can organize that. Like I would be okay with that, at least in the short term. If it starts saying lies about the language, I would have to disavow it or something, right? I don't know. Like we're in early days. It's hard to know what's the best way. We've had very brief stream Fs. Yeah, I'm sorry about that. My internet is not good, apparently. I'm living in a collapsing nation called the United States of America. But it's being locally recorded, so it's all good. Often I have the Twitch chat open so I could see Fs, but I didn't do that this time because I didn't want to be distracted. What plans do I have for extending the procedure declaration note stuff? You work in a team of 20 people and issue tracking project management tools like Jira, which are separate to the code, are a pain. Maybe there's a way the language metaprogram can help. Okay, so my idea from early on that I haven't yet implemented, and again, people can send me to the mail alias what they think about this, is that, okay, so that we're clear what everyone's talking about, right? Let me go, let me go to here, right? So here's the game that we work on all the time, and we have these annotations that we could put on things that are poorly formatted right now. I apologize for this. But what this actually looks like internally is just, it's a string that your metaprogram can parse, right? And that string can have things. So this says v4-7 is the string, and the metaprogram says, oh, those are version numbers, and that's when this field is valid. So you have complete choice over how to do this. And the nice thing about this is it's very simple to understand. Oh, you just get a string, right? The bad thing about just getting a string is the bad thing about every programming language that just gives you a string. It's just confined to a smaller area here, right? Like, what if you import somebody else's module and they use some strings on their data structures that collide with the strings that you use, and your metaprogram gets confused, and then you maybe have to, you could manually go in and carve out exceptions or something, but that's annoying, right? Strings are error prone and you can make typos and all that kind of stuff. And so the idea that I had early on, and I would be interested to hear what people think about this, would be to have we would probably leave the strings for backward compatibility, at least for now, but to have a thing, maybe if you said at or something, right? Then what comes after that is actually a struct literal, right? And then what you get in the metaprogram is that struct literal, right? So you know the type of the struct and the values and all those things, right? And the good thing about it being a struct literal is that now namespace collisions are handled correctly with exactly the same amount of robustness as is present in the rest of the language, right? So if one module has a struct called thing and another module has a struct called thing and your main program has a struct called thing, then the thing that you get is the one that was in scope here or the one that you navigated to, right? And that is a very strongly typed version of notes. It is not in yet. I mean, in part because we didn't have struct literals and stuff. So it was kind of a messy thing to think about when we didn't have that. But that has sort of been vaguely on the roadmap, right? The second thing, though, is it's a little bit like, these are a little bit inconvenient in terms of just when the parser looks for them. Right now, they just go on declarations, which means anywhere in a declaration that you could find one, you could sort of put one in. They don't go on other kinds of statements or expressions, and they don't go on like other arbitrary directives at top level. You can't have a note by itself out in the void. And so that's probably a little bit inconvenient. Again, for our use case in building our software, it hasn't seemed to matter, but I could understand people wanting that. I think there's one other place. I think you can put them in here to put them on the struct type, I think. It's funny that I don't even know that because I never use it, but it's possible to put them on the actual struct, which is different from putting them down here on the declaration, because you could get to them from the type that way. Anyway, so yeah, making those better is vaguely on the list. I don't know what we're gonna do though. Do I see any places in the type system where things could be added to make robust parallel programming easier? I think a large part of that is, okay, I would like to do that. I'm not going to talk about far away unannounced features, because when I do that, what happens is other people copy them for their stuff. There are some unannounced features that I have in mind, but also I think a lot of that can be handled from the metaprogram level. You know, okay, so one of the things I talked about in the earliest talks was having syntactic constructs that would narrow down the namespace that you're allowed to access, right? And that would be a way of just ensuring that, like, oh, this little program that I have over here can't actually get to anything, right? Now, there are some other ways that I could think of to do that I'm not going to mention. But also, that is something that your metaprogram can do. Like, it could look at a file and look at where the identifiers go and say, is that an okay place to refer to or not, right? I think that would be very helpful. in terms of like making sure that you don't access global state that you're not supposed to. Other things like, is there stuff we can do to help with like, using mutexes correctly? I definitely think there is. But that discussion can go a lot of different ways. I would almost prefer to have a special topic discussion on that some other time, because it's a deep subject, actually. Any plans to move the temporary allocator to the context so we can change the way it works if we want to? That's a weird one, okay? I'm not sure what to think about that. Because I was torn when I implemented it, in the sense that part of the point of the temporary allocator is to be really fast. To be much faster than malloc, right? So like, it doesn't have to synchronize with other threads. It doesn't have to worry about you ever being able to free anything. It just goes, right? It knows it has space available. It just goes. Also, it means you don't have to call through a function in direction to get the temporary allocator. Now, that said, the context is pretty much guaranteed to be in cache the whole time for the execution of your entire program, at least that part of the context. Of course, at user level, you could add something giant to the context if you wanted to, but that stuff, all that basic stuff, is packed together at the beginning of the context. So that was just sort of the trade-off I was facing at the time. That said, since then, I have changed the temporary allocator in ways that are theoretically a little bit slower, but that enhance usability, right? I mean, it's still tremendously faster than malloc, but like the original temporary allocator, if you went over the initial allocation boundary, it would just leak. It would just... I think it would just start calling malloc and leak or whatever, whereas now it actually has overflow pages that it cleans up and all that. So you can actually overflow a tremendous amount from temporary storage and it's fine. So it's actually a little bit less simple of a data structure than it was originally. Like, it was originally supposed to be like dead simple, and now it's less dead simple. But that seemed like the right thing to do in terms of making it usable for most people's programs, right? So I could see it morphing further is all that I could say there. So moving it to the context. Is an interesting question. I mean, yeah, like there might be a speed hit there. It might not be a meaningful speed hit, again, because that function pointer is always going to be in cache. At least I could say that now, but more things we add to the context, the more cache we use, right? So there's that too. Yeah, I mean, I think it also depends on use case. Like, how are you going to use it and that sort of stuff. Like, we would definitely have to think about it. There's already a little bit in the way of interactions that I had to think about pretty carefully in terms of allocators being overridden. Like core libraries avoiding using temporary storage or avoiding using context.allocator because they don't know when they're going to run and so forth. So there just tend to be things to think about. But yeah, that's the thing we could talk about. Threading is currently based on function calls. Is there no interest in tying thread functionality more tightly to the language and makes it easier and more natural? No, I would say no right now. And the reason is because I don't have any ideas about how to do that that are good, that are also different from what other languages are doing, that I don't think are the future. Like all these languages have different kinds of threading primitives, and most of them, like with a lot of things, most of them make it easier to solve the easy problem and don't help with the hard problem, right? And I want to help with the hard problem. The hard problem is, how do you actually use all the cores on your computer, all right? And the problem is if you do something like coroutines, right? Or, I don't know, like the kinds of things that some languages have, those constructs are not high performance constructs. They're not, so whenever people talk about concurrency, right? This is a concurrency primitive. They're kind of, I mean, on the one hand, concurrency is a computer science word with a technical definition, right? On the other hand, it can very easily serve as a way to avoid saying parallelism, right? And parallelism is actually what you care about in all cases. Even if you're doing something like, oh, you know, I want to make a web application, it's on the server and it's concurrently calling out to other things that concurrently call out to other things and so forth. Well, you want those things to overlap. Otherwise, it's going to take 3 seconds to load the web page, right? So you actually care about parallelism pretty much always. And so using the word concurrency in too much of a computer sciencey way can run counter to that. And what I see out in the world in other programming languages is a lot of concurrency primitives and really no parallelism help at all. Parallelism is actually really hard. And I think that actually computer science may have done a little bit of disrespect to the actual interesting problems by promoting this mathy thing called concurrency at the expense of this like hard as nails programmer thing called parallelism, and sort of saying that one is higher class and one is lower class when it's actually not. All right. I have a lot of feelings about this that I have to work out. But the point is, like I have some ideas about how to help with mutexes and all these things. I'm not so sure about anything else really being language level. You could imagine a parallel for being nice, but that could be a macro, right? There's no reason, and it's better if it's a macro because you could change what it does very easily. So yeah, I don't know. I don't have ideas for like actual language semantics for that. Are there plans to add complex numbers or 16-bit half precision float? No. Currently, the answer to both of those is no. In general, I don't want to complicate the type system to do things like this. What's special about complex numbers? Like, why wouldn't I then add quaternions and octonions and, you know, geometric algebra with or without the point at infinity? Like, at some point, you have to stop and say these are the types. And I think the place to stop is with scalars. Because if you want a complex type, you have struct, right? So complex number is a struct as far as I'm concerned. 16-bit half precision float is a little bit of a different story because that is a thing that is becoming popular on some kinds of hardware. For now, I would say we wouldn't implement it because for the machines that I'm running on right now, it doesn't matter. But I could see it mattering and I could see us adding it. Yeah. That would be much more in line with the current spirit of the language to add like a float 16 than to add a complex number. That said, historically speaking, it may be too early to add something like a float 16 because I mean, there's a lot of different float 16s out there. Which one is it? Right? So, yeah, I don't know. Like some thought can go in there. You're wondering the current status on debugging with other tools than Visual Studio and what are the plans for the future? We don't do anything Visual Studio specific. We output dwarf files or code view debug files. So any program that does that will work. So for example, I tend to debug using Remedy Debugger and it works just fine. There are some cleanups that we should do in terms of like when you step, where do you go and all that. But that is more about what's in the debugging information than any specific tool. So any debugger that works with these debugging formats should in fact work. However, because debug info is not as heavily tested as language semantics, you might find things that make you grumpy sometimes. I certainly do. And those will get worked out over time. Longer term, if we're going to talk about pie in the sky long term, I want to provide some default program visualization tools that augment debuggers. But I have no business talking about that while we're still in closed beta for the base language semantics. Will I be releasing a game I wrote with the language when it's public released? The demo games that come with the compiler are great, but the Invaders example is quite old. And you imagine I might be writing things quite a bit differently now. Yes, that is true. Everything you said is true. The plan is, so for people, do we still have people on the stream or is everybody left? Oh, there's almost peak. So, I imagine many people may have seen this, but we're making a quite substantial game. That, it's got a full modern renderer and art and animation and like an editor where you could edit scenes and stuff. And, it's a fully battle tested commercial game. There's hundreds of levels, like 700 right now. Not all of them have full art. So you'll see a lot here that don't have nice graphics, but then once in a while one pops up that does. Let me turn up the test speed because this is always fun. But there's a lot of stuff here, right? Let's see if once in a while a nice looking level will flash by, but most of the time you'll see cubes, which is the way that we work on levels in design. Anyway. Okay. Well, and then once in a while, something like this happens where you come out of a level and you're nowhere. Let me try to find another, so this is like an example of a level that we might have. The fade in is still. So this engine will be given out for free as open source, right? So you'll have full source code to the engine. We won't be giving full source code to the entire game because, we need cloners not to clone our game. But we will give out a stripped down version of the game where you have some guys who could push blocks around and do cool stuff with the blocks, right? And probably some art assets, but not enough to duplicate the game. So the question is then, what is the time frame of that? Like, does that happen when we go into open beta? Does it happen later? I honestly don't know because I don't know when open beta is. I wouldn't hold one up for the other, right? So if it's going to be like, if it's easier to release the game before we're in open beta or full release of the language, then we'll just do that, right? Like it would be a very good example program, right? Because it's serious. It is not a toy program, like at all. On the other hand, if we don't want to stop the release of the language, so if this isn't ready for some reason, Like if we just have a hard time, like it's a substantial amount of work doing the thing where you cut things down. We have to probably re-architect the source files a little bit and do a lot of like if-def kind of things and whatever. So yeah, it depends, but we'll release them as we can, and we won't hold up one for the other. This might actually also happen in stages, right? So like maybe we'll release the engine, and if we thought it would be nice to provide some art assets, but it takes a while to organize those about which ones we're going to release, maybe that would be an update to it or something. Will I add the F32 and F64? Oh, I skipped a question. We'll go back. Will I add F32 and F64 type aliases to the language for consistency with the other shortened types? I mean, it is weird, isn't it, that those are called float whatever and the other types are not. I knew that was inconsistent at the time, but it just felt like how I wanted to do it. Will we add those other things? I could see doing that, but you can do it yourself, as one other commenter has said. But should that be should it be standard? Maybe. I admit it's weird. I admit. Someone's porting a program from C++, which is more liberal about implicit casts, and one of the most common compilation errors are type conversion related. Yes. Okay. So people complain about the auto cast, right? So like say you had a bunch of function calls or numeric additions or whatever. The reason the autocast is what it is so that you can go into a program that's not compiling and just do that everywhere. It's really fast to type XX space. That is why the autocast is XX. That is the secret of the stupid syntax. It's because you can hammer the X key and hit space. Now, if I'm porting code, I do that in the beginning. And then I go back and actually see what I can do to fix all the type conversions, right? Because when I write my own code from scratch, I don't tend to have problems with type conversions in that way. But C and C++ code tend to be very messy, and there tends to be a lot of that, yes. Your current impression is that the language seems to push you to use the default S64 type for numbers as much as possible and only rely on smaller unsigned numbers if necessary. Could I talk about how this decision was beneficial? And it's been difficult to think harder. Yeah, okay. So the language is biased toward S64 for sure for two reasons. One, it's big enough that you don't have to worry about overflow for all practical purposes, right? Like either a signed or unsigned 32-bit number is too small for a modern language to use or to encourage you to use. Like, how many 2 gigabyte files are on your system, right? If you can't even load one of those into an array of care in the year 2020, what are you even talking about, right? And so, that's a pretty small file compared to my SSD today, right? Which is size is measured in terabytes. So if you can't smoothly and confidently talk about sizes of data bigger than 1/1000th of a common user SSD, that's a problem, right? And so you want to encourage people to default to S64, yes. Why is it signed? Because if you use unsigned numbers, you can run into rude surprises where you subtract one from the other and underflow very easily, or result in a value that's larger if underflow checking is not present. So signed numbers work more like people expect most of the time. So we do default to that. That said, there's a big difference between are things big in registers or in parameters to functions or as variables at runtime, or are they big on a data structure, right? And if they're big on a data structure that gets instanced a lot of times, I would actually encourage you to think about using smaller numbers because that starts to matter, right? Because not exactly total amount of memory use, because like on a PC, you don't necessarily care that much because you have tons of memory, but your cache use will be much more efficient if you use smaller numbers. And so what I would, and again, this is something we're still working out, like what's the style that we encourage, but I would encourage people to use smaller numbers on data structures and bigger numbers other places, right? But then you know what your data structure will and won't hold, which is a reason why we're so explicit about sizes, right? Like one of the big mistakes of C is, well, I don't know what size an int is or whatever, right? So we don't have that problem here. The thing is, it wasn't really a mistake because you kind of had to do that back then, but today you don't have to do that. You don't have to not know what an int is today, right? So we should just fix that. It fixes a large number of things and it's fine. So I was going to say something else about that and I've forgotten what I was going to say. Anyway, the other thing I would say is like, yeah, I think this is true with a lot of more modern languages. Like if you're writing new code, you just don't worry about typecasts. Like once you're in the groove and you know how things go, it just works and it's clean and it's nice and it all works out, right? It's just porting code over from C or C++ that had a different type system that doesn't make as much sense. You have to deal with it. What are the plans for the future of the LLVM backend? In one hand is a dependency that would be good not to have, but you're afraid of losing support for all the targets. Yeah, so what I would say is, as far into the future as I can possibly formulate plans right now, the LLVM backend is part of the compiler because yes, that is how we would target platforms that are no longer supported. And it's also currently how we build optimized builds at all because our backend doesn't have optimization in it at all right now. Now, over time, our optimization should get better, and then the amount that you would have to rely on LLVM goes down. But I think it's a valuable component in that it supports a large number of things. But it also, in doing that, it has that problem I was talking about with modules earlier, about it's the giant cargo plane of modules and not the small agile aircraft, right? And so LLVM is really slow. It takes a lot of resources. It's annoying to compile against and all these things, right? It's very annoying to program for. Oh my God. But, you have to respect it. It does provide useful functionality. So is there a day when we would ever remove LLVM? I mean, if that day comes, it's far enough in the future that I can't see it right now. Or it happens because somebody else comes along and provides a better alternative that we could use instead, right? That said, we are also not, we very explicitly make the choice not to rely on LLVM. LLVM is not an integral component of the compiler. The entire programming language functions without it. And if LLVM exploded tomorrow for some reason, we could just turn it off and we would be sad that we lost some capability, but everything would work fine. And that's very important when talking about having this hygiene of keeping a system that is understandable and and simple and works as well as possible, working as far into the future as possible. So that's the current viewpoint. I'm sure if you ask me this time in 2021, I'll have an answer that's further along. But that's where we're at right now. What are your plans to handle language stewardship after it is public? Will it still mostly be a one-man show, or will you focus on other things and delegate? this is an unsolved problem for me. At some point, I have to focus on other things and delegate. I think that's unquestionable. For things to scale, that has to happen. However, doing that too soon can be a mistake, right? And so for me, it's a question of what's the timing of that and what does that look like? And right now, I don't know. I'm not close enough to when that would happen to see what it looks like, but it is something that I would like to solve correctly, right? That's all I can say right now about that. How likely is it that this ever runs on a 32-bit system? I don't know. So right now, the compiler makes assumptions that it's a 64-bit host system and 64-bit target. Let's put up a more entertaining image again. None of those assumptions are particularly, are we? Yeah, okay, I'm little. I was like, wait, I haven't had the thing up. Have I been talking about the game with just my face really big? But that wasn't what it was. Good. So the question is, I guess, there's two questions, right? One is the relatively easy question, which is like, is it possible to make the compiler run on those platforms? And the answer is yes. It's not that hard, right? There's actually, if you add up all the places where for simplicity, we assumed 8 bytes per pointer or whatever, it's a substantial number of places, but pretty much none of them are hidden gotchas. They're all like outlined in the code. We know what it is. We know what we would change to do that, right? That's just grunt work. The question is, should we do that grunt work? And for now, the answer is just no, by virtue of conservation of effort, right? Like there's just things that are higher on the priority list. And here's the hard part of the question. How much complication is added to the language by saying things can be 32-bit, right? I don't know the answer to that right now. We don't, like I said, we don't have the kind of problem like you have in C where like, oh, maybe int changed, right? Int wouldn't change. But that would also mean that a lot of code would run by default slower on your 32-bit CPU because it's using 64-bit ints all over the place, right? So you might not want that anyway. But that's a thing that I haven't assessed very carefully is there's two dimensions of complexity, right? How much does the implementation complexity of the compiler go up if we support that? I think it would be non-trivial and it might be quite painful sometimes. And the problem right now is the gating factor on how much gets done is the complexity of the compiler, right? Compilers are in general very complicated. This one is super complicated because it does a lot of crazy things, right? And so the question is, how much do we pay in terms of rate of progress in order to support 32-bit? That might be very high. And then how much do we pay in terms of end users having to deal with harder to understand semantics if we also support 32-bit? And that is unclear. I just don't know the answers to those questions. So I'm not raising those problems as saying those problems mean therefore that we won't do it. I'm saying those problems need to be assessed and the impact measured. And then based on that, we could make that decision. But right now, again, while it's just me doing this stuff, it's not going to happen, like practically speaking. After it's not just me anymore, maybe we have to figure it out. This test for this level broke, so she's just running around in a box. Okay. Is that all there is to say about that? I think so. I think I need to get through more questions. I'm going to skip name questions because I never answer name questions. There's a class of problem for which compile time metaprogramming is very useful, but for which you don't necessarily want to spend the time at compile time every single time you compile your program, say bindings for external libraries. Have you thought about building more code generation caching of compile time results into the compiler, something like a stickier version of .build.added strings? The easiest entry for metaprogramming in the language right now is basically using insert like a preprocessor. Manipulating code nodes can be unwieldy. Oh, these are two separate questions. Okay, hold on. Let me get the first question. Let's keep up the entertaining background, but let's turn down the test rate and run it. Oh, 30 is still pretty fast. Like, it doesn't play the correct animation, so if I play it too slow, then it's obvious that the animations aren't right. But, you know, at a speed like this, it could be fun. Actually, at a speed like this, we might spoil people. I don't know. It has to be so fast that you don't see the answer to the puzzle. Okay. Have I thought about building more code generation caching of compile time results? Okay. There's a very specific problem that was brought up that I think is a real problem, and I prefer to start from very concrete real problems, right? And that one is, if you're maintaining bindings for a C or C++ library that changes over time, that's very error prone right now. You know, we have a thing in examples that sort of tries to do that conversion, but, you know, it relies on external tools. And again, that makes it hard to use and breakable and like, I don't know, right? But also the thing that makes this process error prone is that you know, if bindings change, you either have to have a fully automated way of regenerating them, which may mean that then they're ugly and you can't do personal touch-ups and stuff, or you just have to somehow notice which ones changed and make sure that those function signatures are updated. And if they are not correctly updated, the result can be quite painful. I could actually think of some ways that might help with this. Like, one thing that we might be able to do is actually, you know, right now you specify the name mangling if it's something like a C++ function. We may be able to look at that name mangling and just see if it matches the parameter declaration. I don't know what's going on with that level. I need to look at it later. It's just a bunch of hammering on the teleport button. I can definitely see whether that is reasonable or feasible. I don't know. Like, the C calling convention, even before you talk about name mangling, is a huge headache that we probably still don't get right in 100% of cases. But that could be a good extra layer of verification. If you turn, like, you could have a directive that says like, hey, check this, or maybe it's a metaprogram thing. Hey, check this. But that also just seems more like a tool thing. I don't like tools. I don't like the idea of tools. I think one of the big problems today is we have tools. But sometimes you need tools, right? I don't know. You know, that's a thing that I would like to solve that I don't have a clear answer to at this time. Okay, the allocator and allocator data thing we mentioned in the closure answer. Do I have plans for a foundation or similar to maintain the language? Yes, in the longer term. Yeah, that's part of the scaling and, you know, making myself not be the bottleneck anymore, but I haven't worked out the details. What are the plans for intrinsics? Oh, I'm sorry for missing the question. Does the LLVM backend auto-vectorize anything currently? We'll take that second one first since it's easy. I do believe it does auto-vectorize sometimes. And I believe we give you enough build options to control that, or if we don't, we should, because it's just passing stuff to LLVM. I am not a huge fan of auto vectorization. I think you will do much better to vectorize by hand. However, we also don't support inline assembly right now. So that is, we don't give you the tools to vectorize by hand. So that is, to evolve in the future. The plans for intrinsics. All right. So right now, so far, we've been adding intrinsics for lots of popular things that people might do. This approach doesn't really scale. So like one of my favorite web pages to visit when I'm talking about intrinsics is on Wikipedia. It's the page for AVX 512 on Wikipedia, and you can look at how many instructions there are, right? And if we make intrinsics for all of these, it adds a lot of workload. It's a pain in the butt. It's like bigger than, this is several times the size of all instructions we support currently anyway, at least in terms of our intermediate representation. It's just terrible, right? And so what I would like to do is probably handle this kind of thing with inline assembly in such a way that the assembly blends very well with your code, like Visual Studio used to do, right? Like in older versions of Visual Studio, you could write a function in C or C++, and then in the middle of the body of that function, you could insert some assembly that uses the variables and whatever, right? And it would just work. So if we can do that, that would be pretty good. You wouldn't really need intrinsics for these things. And then especially we could make macros that, wrap larger sets of these or so forth. That is the current plan. Whether that's the best plan, I don't know, but that's the current plan. Do you plan on releasing a memory safety metaprogram in the standard library, like an optional, less restrictive Rust borrow checker? I plan on providing whatever good safety checks that we can. The problem is, if you try to do the Rust thing, what you will find is you can't really do it unless you are Rust, right? Like one thing that people complain about with Rust is that it's very intrusive and they run into walls all the time and stuff, but that's not arbitrary, right? The reason that happens is because that's what the language needs you to do in order to let it have enough knowledge and control over what's happening to actually do the memory safety, right? Like there's this old thing in AI called the closed world assumption, right? Where if you have a an AI that's reasoning about a world, as long as it knows everything in the world, like certain techniques apply. But as soon as there's things that it doesn't know, that's a totally different, much harder problem, right? And so optimization is like that. Like aliasing is like that, right? Like if you know everything in the function and where the memory can come from and all that, you can do a good job of knowing whether two things alias. As soon as there's one pointer in that function that you have no idea about, you don't know anything all of a sudden, right? So that is the problem that you end up having with that style of checking. And so the question is, what kinds of safety checking can you provide that are in actual practice very useful, but that don't require that much of a closed world assumption, right? Some of my favorites, so one that I brought up on a stream the other day is like, look, you can replace your allocator. This is a runtime check and not a compile time check, right? But it's, again, a thing that we could provide. You can replace your heap allocator with one that puts every allocation on its own pages, and on free, it turns off read permission from the pages so that there's no way to dereference it after a free, right? Like your program crashes instantly and then you see that, right? And you can do similar things for buffer overruns and stuff. Sometimes those are very slow, right? but these are kinds of things that have been done by third-party tools that you usually pay money for, you know, like Purify was an example that I forget who owns Purify now. Does IBM own Purify, or like Intel? Somebody owns Purify. But that's a kind of thing that you can do without a closed world assumption. But that's also strictly less powerful than a compile time check that was 100% guaranteed to be correct. Right? So we just have to look at those. But yes, I'm very interested in helping people spot problems as quickly as possible and as painlessly as possible. I spent many years programming in C and C++, where I spent a lot of time debugging things that the compiler could have just told me about very simply, but the people who made the compiler, quite frankly, didn't care enough to do it, right? And that makes me very angry. I could be a much better programmer today if I had spent that time programming instead of debugging. And so anything that we can do to make that better, we will. Now, that said, a lot of my time is still spent, you know, implementing fundamental stuff, like, for example, this module thing that's coming up. But to the extent possible, yes, I want to do a very good job there. What is the current status and or your view on dependency injection and compile time arguments for libraries? There are module parameters right now already. They're not documented though. If you search for the modules for module underscore parameters, you'll find them. We just need to make them a little more first class and document them. They work just like function parameters where you can provide defaults and all that stuff. I'm pretty sure nobody knows about them but me right now. Would you be open to do macros that are more friendly to pass in code parameters? I'd like it if a macro to a code variable, you could just call it like a keyword. Oh, you mean like the trailing lambda kind of stuff? Like, yeah, we could think about that. I mean, that's not like, okay. Things like that would be nice. I think that things like that are, those ergonomics do matter in a final finished programming language. But in the shorter term, let me just paste so that the people at home can see. We didn't actually agree to, expose anyone's identity in this questionnaire. It's probably fine. Probably the people asking the questions don't care, but because I didn't establish that beforehand, I don't want to just like pop the questions up. But you might be able to see it when I alt tab. Sorry. Anyway, you know, the question is about being able to do this sort of thing versus this sort of thing. And the answer is yes, maybe. And that would be a thing that we consider in a syntax pass. But when it comes to macros and stuff, I think there are bigger fish to fry right now, which is just making it easier for macros to do the full gamut of what they could do in principle with compile time execution and all that stuff. Okay. Oh, wow, I'm toward the end. Oh my God. All right. Been keeping notes about what you've thought about the languages you've been learning it, figuring to write it up further down the line when the compiler is stabilized somewhat. Is that preferred, or would I rather get feedback right away? I would say bug feedback I would like to get right away. If you're super confused about something, I'd rather get that right away. Opinion feedback, like about how much you like versus don't like various things, that can wait till later. Like, honestly, that's not my favorite thing to read anyway. I would separate it into those two different classes. Like, bugs and confusion are good to do now because those impact other people's experience, right? If there's like a confusing error message, or a feature doesn't handle something in a way that it should, and somebody doesn't report that, that means that other people can run into the same problem, right? Whereas if they report it and I fix it, then, et cetera. Have you considered adding annotations to other things besides just declarations? You would like to, for instance, be able to add an annotation to parameters passed to a function. This could be used to package your parameter to the function at compile time. Yes, it definitely feels like a hole. I meant to say this before. It feels like a hole in the current semantics that you can only put these annotations in certain places. It's not that obvious how to do it, though, if they can go anywhere. And the question becomes, like, how do we store that data? Like, how do we make that data available to your metaprogram in a way that's convenient, for example? And I'm not sure what the answer is. We might have to switch to a system where it's more like, here's an array of the relevant annotations and then indexes to where they are attached to. I don't know. That might be faster, though, also for the kinds of queries that people want to do. What's the current compile time of the game? It is... so in the actual compiler, we spend, while streaming and use a lot of our cores for streaming, it's about 0.75 seconds in the compiler, which is, that's a debug build with no optimization with our own backend and our own front end, obviously. So that's for this much code, 100 to 150,000 lines, depending on how you count. This line count does include the modules that we use, right? So this is main program plus all the modules being computed from scratch with no incremental build. Then because the linker is a saggy butt, this is using LLD, I think. Yeah, we're using LLD. LLD takes almost as much time as we take to compile in order to link. That's sad. There might be some things we can do to reduce load on the linker, but honestly, the load on the linker isn't that bad. It's much lower than it would be for an equivalent C++ program, tremendously lower. So I don't know, man. I would like to get rid of the linker eventually, but we kind of can't because we need the ability for people to link against libraries written in C or C++, and that's going to require a linker. If it were just up to us with our own language, we wouldn't have a link phase. And we would get rid of this half a second. But, if I'm not streaming, this is about, 0.07, 0.08 seconds faster. So this lands in the 0.6 something period. So the reason this is broken down is this is the number that we can do something about by optimizing the compiler. This is the number we can't really do anything about. It's beyond our control, at least right now. How are Twitch peeps doing? Very intelligent questions happening in the Twitch chat. Okay. Have I considered a command line option to swap between release and debug builds? Maybe. I mean, here's the thing. If there's a default metaprogram, then that default metaprogram could take some options, right? And they wouldn't be things that are built into the compiler. So the compiler itself would be simpler. These would be things that would be in the metaprogram. So I think maybe that takes care of that. I hadn't thought of that, but it's a good point. In fact, I like that a lot. I think that's going to solve some things. Even though the philosophy is a lot about recompiling the code, it's very natural that a lot of companies will want to release libraries instead of the source. Are there any plans regarding libraries built here? Any ideas on how that will work? Okay. You can already, of course, build libraries in the same way that you would build a library for C. You can build a binary statically or DLL, right? That's fine. The thing is, when you do that, you lose a significant amount of the power of the programming language, right? Like if a function is compiled, you can't polymorph it, right? You can't bake the arguments. Your metaprogram can't know information about what's inside it. Well, I could imagine storing that with the thing, but the same kinds of companies that don't want to give out their source code also wouldn't probably want to give out that information, right? That said, I'm friends with somebody who runs a company that quite successfully sells third-party libraries to several industries. And he said that just a reasonably far from source binary format, but that, didn't have to be machine language or something, would be good enough for them. Like hypothetically, right? This isn't any company with like concrete plans to switch. I mean, clearly not, no. But like, just talking hypothetically about what would be acceptable to a company like that. Of course, every company sets its own agenda, whatever. But the goal tends to be to prevent the simplest thing, which is just copying the source and compiling it yourself when you didn't pay the license, right? And also defeating low-hanging fruit reverse engineering, right? But anyone who's very serious about reverse engineering can decompile your machine language anyway. And like, they have something that's a first approximation to the source of your thing anyway. So the long-term plan, this isn't anywhere on the short-term roadmap, but the long-term plan would be to provide a format like that for people who don't want to distribute source. And we'll just see, as it gets closer to that time, we would sketch out the parameters of what that looks like in more detail and just see if that actually, solves people's problems or not. Ideally, it would also be something that's faster to compile, right? Or something. Like it would be pre-parsed, pre-tokenized. The thing is, parsing doesn't take very much time, right? It might have type annotations already for the majority of things, but that would have to be optional because the guys who want to distribute their thing, again, don't want you to have that information. I don't know. Like those details have to be figured out. Time for a compilation is already that you know of the best for a language of this kind and this level of features. You mentioned that there are still improvements to be made. What are the next things to tackle regarding this? How much of improvement do you think is achievable compared to the current implementation? I think you're talking about improvement in compile speeds only, right? Because of course there are lots of improvements elsewhere that we've been talking about. So this number is largely single core performance, and I'm on a machine with like 8 physical cores right now. I think 8, maybe 6. Anyway, a substantial number of physical cores. When you use the LLVM backend, we split that into 4. That's hard coded right now. We just split it into 4 threads, but that's just to try to get LLVM to not be so slow. It doesn't make particularly efficient use of those cores, right? But in our front end and in our x64, this is mostly single threaded. We do have some multi-threading happening when we parse things and when we pack messages for sending them to your metaprogram. Those both happen in parallel, and that brings this number down somewhat. But both of those things are also kind of fast. The slowest phase is type checking, and it's also one of the hardest ones to parallelize, right? Languages like C and C++ and most modern languages think that they're using all your cores to compile by compiling a bunch of separate object files and then linking them at the end. But they're not, because most of what the cores are doing most of that time is waste. And if you want proof that it's waste, here, this is existence proof that most of what those things are doing is waste because they take much longer, right? The way I try to explain it to people is well, people in the game industry, programmers in the game industry, I would say, you know, if you want your game to run fast, the last thing you would do is take all your scene data for different parts of your scene, write it out to disk, have a separate process, read it in from disk, put it together and draw it on the screen and try to do that 240 times a second. Like nobody would do that, right? But for historical reasons, we've decided that that's the way to compile things and that that's even efficient because it gives you parallelism, but it really is not. Just look at the compile times. Now, that said, there are mitigating factors that make it not so clear to see. So for example, C++'s compile time is largely dominated by including massively redundant header files and then deduplicating that massively redundant information at link time, right? But even so, even if you got rid of all that stuff, it wouldn't be that fast because it's writing all these .o files out to disk and then linking them, right? That's just an inherently slow operation. So, you know, so in terms of making this faster, it would just be actually parallelizing more of the compiler now, which is not that easy. I've been restructuring the compiler in a direction to make it more feasible, but it is a long-term project. That said, there's some shorter-term low-hanging fruit. Like there's a bunch of stuff that right now probably is, I haven't even profiled this compiler in a year, okay? I actually want to make that a fun project before December 31st to just run telemetry on this again and just see where the time is, because I haven't even seen where the time is in like a year. And I wouldn't be that surprised if we could get a 10% improvement in a night or 1 or 2 days in this number, just because I can think of some stuff that's probably eating a lot of time that shouldn't. So there are definitely short-term things, but the big long-term improvement is the multi-threading, and that's not easy. You would also like a more general for loop. Yeah, I mean, I think we try making that as a macro and then see how it goes. Of course, making it a macro brings in that complaint about the code block at the end. So maybe that would raise the priority of inlining the code block. We'll see. In order to support IDE diagnostics, it would be useful if the compiler reported all errors instead of the first error. Is there a plan to support additional error reports from the compiler? That's a long-term thing, probably. The thing is, you just need slightly more sophisticated tracking within the compiler in order for that to make sense. So C and C++ compilers report multiple errors, but not well, because most of what they report is garbage, because you know, the first report made the compiler return some dummy value or pretend like a variable didn't exist or whatever it does. And then the rest of the reports are not the real problem, right? So to report error messages correctly, multiple errors correctly, you need to know what you did as a stopgap in order to continue compilation in the face of the first error and just not report further errors when that happens. There might be some ways that we could do that. I mean, there's some pretty well understood techniques of doing that. They just added complexity to the implementation when I started doing them way back, so I stopped doing them. We may do that again in future. Some things are easier than others, right? Because parsing goes in parallel, right now we actually do report multiple parse errors if they occur in different files, right? If you find a parse error in one file, it's unlikely that you're going to parse the rest of the file even correctly, so it's not that helpful. But parse errors in multiple independent files, we usually will report, the exception being if we didn't get around to loading those files because they were going to come in a later time in compilation, right? Yeah, so I would say that that's a longer term plan. It's a little lower priority, so it probably won't happen for a while. Do you think it'd be useful to know what stuff is taking most of the compile time in the same way we warn about structs having too much type info? Might be cool if we'd warn for things like the run directive takes up 50% of your compile time. I don't know. I don't think that should be a built-in compiler warning because, again, I'm very anti-warning culture. But having your metaprogram be able to see that, I think would be good. Yes, for sure. And then you could generate messages about that or a summary about it or whatever. Sometimes it could be challenging. Like individual run directives is not that bad because that's a very clear thing that you might want to profile. How much CPU it takes to compile every function might be a little harder to measure. We'll see. A while back, we discussed about using this language kind of as a scripting language, but it still has some overhead to set it up. Any plans on improving this? I mean, for now, the only real overhead is you have to put main or a run directive, right? I kind of just want to focus on one use case right now. Like right now, the scripting language use case is just kind of fun. The compiler is not meant to be a long-running process. So if you ran it kind of in script mode for a day or two, it would probably use a lot of memory. So that's, I don't know. We just have to see where that goes. It's not the primary intended use case in the short term. I've really enjoyed writing in this language. It really brings back many of the good feelings. This is going to be the last question for now. I need to take a 5-minute voice break after this, and then we'll continue. I mean, I'm good to go for a little while yet. I just need to like get a cough drop or something. I need to relax more when I speak and let my voice just like, but I don't. My voice is way up here all the time, and it just, after a while, it adds up. It brings back many of the good feelings I had while programming in Turbo Pascal many years ago, and I've rarely felt since then. Thanks for creating this language. You're welcome. I'm glad. It's one thing to say you want a language that's fun to use, to make one, and another thing to actually get that kind of feedback. So that's good. You're impressed. 34 beta testers were online for this stream. Oh, that's cool. I didn't see the number, but thanks, beta testers, for coming. I think we should do this semi-regularly. I don't know how often that is. We might also try different formats, like maybe we could have people come on a voice channel and have back and forth discussion, or I don't know. Maybe I wouldn't like that. Maybe people don't want to do that. Maybe it's easier to do text. I don't know. But we can entertain different things. It might be useful to add a couple channels to the Discord. That's probably true. I don't want to make a bug report channel though. Maybe a questions channel for me, but I want to keep official bug reports going to one place. Since if there's multiple places, then people who send reports don't really know if they've been received and stuff, right? So one place is good. All right, I'm going to take a voice break. Thank you everybody for coming by. Feel free to leave if you're tired of listening to me yammer on. In 5 minutes or something, I'll come back and here, let's put up some entertaining background for the break. I'll come back and we'll do maybe more questions or maybe questions from the Twitch chat this time. About that scripting question, you need to make the compiler not search for entry point. Oh, yeah. Right. Okay. I see what you're saying. We could think about that. Yeah. Like if there's a hash bang at the top of the file, then the default is no output. I mean, that's a little bit weird and squirrely, but we could do it. Actually, rather than building that into the language, we can set a variable that we started with a hash bang, and the default metaprogram can then set the build type to no output. Dude, I'm getting hyped about this default metaprogram thing. I'm getting hyped about it. Because then we can make it do whatever, and if someone doesn't like it, they could change it, right? Which is the ideal for that kind of thing. You know what might be fun too? Okay, so the format this time was all the beta users are invited. They ask a bunch of questions. I go through the questions, right? I wonder, like, if we wanted to try to have more in-depth conversations, what if we, like, I don't know, this might be a stupid idea, but like, what if we broke the beta group up into sections and had smaller groups at a time once in a while, and just, it was just like 5 or 6 people total, and just have a discussion. It could be on pre-announced topics and people sign up for it or something. Because then it could be like, you know, more interactive and more, just more going somewhere continuously, right? Whereas, you know, with this time, it's like, it's a little bit less interactive in a sense, because there's a ton of questions, and by the time I get to the bottom, it's like 45 minutes after the question was asked and stuff. Yeah, so maybe we'll do that, and maybe they could surround maybe some of the upcoming features, or maybe there could be a general questions one. We can talk about it on the Discord later. How's Twitch chat going? Wait, where is my Twitch chat? There it is. By the way, Casey, I didn't mean to be poking you too much about slipways. I totally know how it is trying to play something like that when tired, man. It's like, it's rough. It's, I mean, I hope, okay, this might be an age thing, but sometimes lately I'm programming and I'm just like, I'm too tired to do this right now. It's usually for hard things, but like, it's making me starting to wonder, like, do I lose my ability to really program serious stuff at some point? I hope not. Maybe I'm just tired lately because I've been working hard, but like, I could sort of imagine what that's like, and it worries me. I mean, of course it'll happen eventually, because at some point you're just dead, but hopefully up until that point, I can continue to do a lot of good stuff. Okay. Are there any questions from Twitch chat that, I mean, I may skip a lot of the questions, honestly, but we still have a good number of people here, so that's great. Questions from Twitch chat while I pour my tea. I'm seeing a lot of sarcastic, not on-topic questions. Concerning temporary allocator in context, use a system with 3 allocators in context: default, persistent, and temporary. Code like rendering uses persistent allocator since it doesn't know if default allocator is temp when it is called. Okay, so there's some nuance to this question. Your own program at user level is free to add whatever it wants to the context, right? So if you have a particular system of allocators that you want to use, and you want those to be in the context because that's a convenient place for them, you could do whatever you want, right? And so the question, like, you could use a totally different temporary allocator, whatever. So the question that was being asked really is about what's the default, and which is actually important because the thing is that the default sets the convention for parties who don't know each other to coordinate, like people who make modules with you who is writing a main program or whatever, right? And so that's the thing, right? If you want your own temporary allocator that works a different way, you can do that right now. very easily, and it's no problem, right? The question is just, if code that you didn't write uses the other temporary allocator, do you care? Maybe you don't, right? So that's the situation there. Will you be able to program low level? I mean, depends on what you mean. You totally know what I mean? Yeah. I do want to play Slipways, but I also just have a lot to do right now. Maybe I'll bug him. Maybe after he incorporates your bug reports, I'll get the next build or something. I'm glad that game's coming along, man. Slipways is, it's going to be good. I mean, it's already good, but you know what I mean. Oh my, a lot of questions came in. I was scrolled up. Do I have any plans for targeting consoles? Yes, there are plans for targeting consoles. No, I cannot talk about them because the console vendors generally just don't like you talking about these things. That's the reality. I'm sorry about that. Let me put it this way. This game that you see right now will ship on at least one console. That's just what will happen. Probably multiple consoles. Will we develop using multiple APIs, graphics APIs for the Sokoban game for multi-platform support? Yes. The reality is you just have to do that in the modern day if you're making an engine. It's sad, but it is what it is. Do I have any plans for graphics language features? Not currently. I don't really know what would be a good feature to help with that kind of thing anyway. Could I elaborate on the idea of a default metaprogram and the sorts of things you want that to be able to do? I mean, nothing fancy. But, error checking and warnings like I was talking about. We just came up with this hashbang thing talking in Discord. That sounds like a good candidate. Like things like that, where we don't want the actual definition of the language to be encumbered by them, and we don't want you to be burdened by them if you don't agree with those choices. But that are a good idea to have, especially for new people who just sit down and start using a first program, Regarding SIMD intrinsics, would it be possible to write a metaprogram that bulk imports everything from imintrin.h? No, because intrinsics have to be implemented inside the compiler. That's the point. And for us, we have to implement everything 3 times right now, which makes it really not fun. It has to be once for each backend, our backend, LVM backend, and then compile time execution is its own thing, right? And you can't just, optimizers need to know what the opcodes mean. It's crazy. Just things. There's things. For scripting, you assumed it would just do a debug compile and run it immediately rather than use run for the whole thing. Well, we could think about that. That's not how it does it right now, but we could think about that. Don't I think that operator overloading is a very OO thing and introduces too much complexity? When I first got into C++, I definitely saw a lot of bad operator overloading. However, there is also good operator overloading. Like in games, we use times and plus on vectors and matrices all the time. And that's a good thing to have. So I don't mind it. We do, in this language, have a relatively limited scheme of operator overloading. We don't try to let you use any punctuation or whatever. So it's not a feature that we expect you to use heavily. The model is, hey, it's for math, right? If you use it for math, great. If you use it for something besides math, you're probably going to make someone cry, is the current idea. Who knows? As things evolve, we may see where it goes, but that's the plan right now. You hope I'm not going to copy the GCC inline assembly syntax. So do I. Have I given Casey's idea of signedness being tied to arithmetic operators rather than data types another thought? I mean, not seriously, just because I have too many other things to think about. At some point we will, though. Which features was I hyped about at the beginning that were changed or removed? Memory ownership on data structures was removed because you shouldn't have that many dynamic allocations in a modern program. Or how do I say it? You shouldn't have that many independently managed pieces of memory, right? If you're mallocing a ton of nodes that you need to remember membership about or ownership about, that's bad. So as my understanding of that evolved and clarified, I realized, yeah, that's not actually a very good feature. It's much better to have something like temporary storage, right? Where you say, oh, this thing, we don't worry about ownership, rather than we track ownership. So that's an example. Slipways is ballet. You meant baller, but type ballet. All right. You were saying it wears a really big cod piece and dances around. What do discriminated unions look like? They don't. A discriminated union is basically the same right now as it is in C, where you have a struct with a slot with an enum in it that you happen to know what the enum is, right? Uh-oh, I just Alt F4'd on the game and it closed Twitch chat. Let me see if it comes back when I pop it out. Oh, it did. Wow, somebody at Twitch did some work. Oh my God, I probably lost a lot of the questions, but I got some of them. Yeah, that is how we do them in the Sokoban game right now and all that stuff. There's the question of, is there a worthwhile shorthand on top of that? Because people seem to want that sometimes. It's very trendy in programming language design to do that. In reality, to me, it doesn't cause a lot of problems to not have that. So I just haven't worried about it, and it's not a high priority. That said, since types are first class, if I were to implement it, I would think about having a way to declare maybe to declare a function that maps an enum to a type. And then based on that, maybe a standard library function could do the rest. It seems like mostly a user level thing at that point and not a compiler thing. In general, there's a broader question about this. People who are all worried about discriminated unions also tend to be all worried about non-nullable pointers or references or whatever. And I would rather think about non-nullable references. We don't have those right now for reasons that you probably understand. For me, in a systems programming language like this, if you were going to say something's non-nullable, the thing is, but actually it is going to be null at some point anyway, because if it's a field of a struct, I have to allocate and initialize that struct, right? That field is only non-nullable to people who are ignorant of what happens behind the curtain, right? So, but maybe that's fixable by saying having a directive that says, hey, we're behind the curtain right now and we're setting this thing up. And then after we've set it up, it's non-nullable. And how do you avoid the problem that you have in C++ where you have some reference and you're 20 functions down and it's suddenly null and you have to figure out why? Well, just like we have compile time array bounds checking in debugs builds, we could have compile time make sure this thing really isn't null checking, right? And like stop as soon as it happens. But clearly I haven't implemented that, so it's not a super high priority right now. What do I think about the thing Zig is doing where the allocator is an argument to functions and consumers can choose the particular one they want even for the standard library? I don't know what Zig does. I mean, people in this language can already choose the particular allocator they want, so I don't see that as a problem that we have. It's already solved, so. But I don't have an opinion. Don't ask me about how other languages do very detailed stuff, especially if they've done them in the past like 5 years, because I've been too busy working on this language to like, you know, spend time using other people's languages. Would I discourage people from building serious things while the language is still in the beta? I wouldn't discourage that, but I would also say you need to be a little bit prepared to track, you know, significant changes in the compiler and or the syntax, right? With the syntax, you know, assuming we do a major syntax pass like I've been talking about, we would provide a rewriting utility. So you hopefully wouldn't have to do much by hand for that. But still things happen sometimes, you know, like, oh, this was a function that we got rid of because we didn't like it or whatever. That said, again, once the module change goes in and you have your own local copies of modules, you'd be less affected by that as well. By low level, you mean handle memory management. Yeah, there's lots of memory management stuff in this language. You could watch the YouTube videos for examples of that. Regarding threading, in your experience, task-based parallelism is a good way to properly use the cores and still easily modularize. What does that mean? What does task-based parallelism mean? Do you mean like each one is a separate process in the operating system, or because I don't know what that phrase, maybe that means something official to people. To me, it's like if I parallelize something, yeah, it's doing a task because it's trying to do something that I want the program to do. So yes, of course I'm parallelizing it. Like what? Is it feasible to use x64 as a compile time execution environment? God, no. No, 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 no. No, 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 no. No, 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 no. No. Oh, well, actually, never mind. It depends on what you mean. If you mean interpret x64 machine code, then no. That's what I was thinking of. But if you mean just like JIT compile and run that is feasible. You know, if you're running on an x64 CPU or whatever, if you're running on a CPU that we have backend support for. But if we change the architecture over to that, then we lose the ability to run on architectures that you can't target, which maybe is fine. Maybe. But that would be a big change, so we're not worrying about that right now. Right now, we're just keeping it an interpreted system. Are there strong type defs? There are not right now, but I want to add them because it would be useful. Maybe option non-nullable types are rarely useful in practice, you have found. Yeah, I mean, the thing is, sometimes it's all anybody ever wants to talk about. Like they want to tell you what to do in your language. And they say, you should have option types. And if you don't, you're just not as good as Haskell script. And you're like, dude, I don't know. But, sometimes it's just people being enthusiastic about programming languages, right? Something like that. Okay. None of this is to make light of the actual goal in many of these cases, which is to establish language semantics that are less error prone, that are cleaner, and that make it less annoying to do things that you commonly want to do. Like, I'm fully on board with all of those. But the problem is, a lot of the time, the mechanisms invented to accomplish those tasks don't really accomplish those tasks. And in fact, have drawbacks that are hard to see and that people do not properly account for. So that is why, for example, discriminated unions were not built into the language from day one, because I was like, they don't actually solve problems for me. Not really. Like, I don't generally have problems that those would help with. I might have, although some of this may be experience level. Like, I might have, way back when I was a C programmer early on, made a lot of mistakes about that. But those were also times when, like, I started learning on KNRC when, like, function arguments weren't type checked. Actually, I think my compiler was ANSI C, but I didn't know that. And I was learning from the KNR book, which told you to type all the functions with parens. And the compiler, of course, accepted that. So I think I could have saved myself pain, but didn't know how to do it. That was great. Thanks, KNRC book. Do I think porting libraries from C would be a good starting point? Do I think it would be better to write them from the ground up? It depends. Like, just if you're porting a library over, just be ready for some amount of grunt work. That's just how it is. And the thing is, anytime you port anything from one language to another language, what you get, unless you use that as a starting point and then refactor it a lot, in general, what you get is non-idiomatic code, right? You get code that isn't really the way it would have been if you'd written it in that language in the first place, usually, right? So you just have to be aware of that as well. Does the language support long double? Not currently, no. That would be a thing that if you wanted it, probably in inline assembly. It's not a very standard thing. I have, the only times I have ever used long double, it was a long time ago, and it was in ways that were honestly just kind of hand wavy, spray and pray, like, oh, I hope the long double solves my precision problem here, rather than actually fixing my precision problem by being robustly analytical about it, you know? I don't want to answer broad questions like what high-level goals do you have in 2021. I told you guys, if you missed the roadmap that I laid out at the beginning of the talk, you can go back to the VOD and watch that. That is what I have to say about the future. They updated KNR for C89 later on. I know. It's just that's not the edition of the book that I learned from. Will it be possible to use the metaprogram to mass rename an identifier or other such things that would reduce the need of an IDE? I mean, I don't know what you mean by that. Like, I guess you can do that. Do you mean find everywhere that an identifier is used. Oh, I see. Yeah. I mean, okay. So the thing about the metaprogram is you can actually tell when the thing has compiled which variable or which declaration this identifier actually bound to, right? So if you have a bunch of identifiers named foo, but you only want to rename one of them, you have that information unambiguously inside the metaprogram. And so we don't provide a library that serializes out that information yet, right? But you could serialize all that out and then have a program visualizer read that in, or have your editor read that in and use it for search and replace or whatever. Or you could actually write a metaprogram that does a search and replace on all the files. That seems like kind of a niche use case, though. I feel more like you would export the information and do that from an editor. You use discrimination unions tag field in many different creative ways that actually help to solve some problems. You don't see a way to make it into a well-defined language feature that you can just handle this required flexibility. Yeah, I mean, all that I could think of is to let you declare the tag field like you would currently, but then tell the compiler that it's the tag somehow, and then have that turn into something, right? What about the Oscar-winning The Long Double, starring Steve Carell and Ryan Gosling? I mean, I know that's a reference to some movie, but I don't even know the name of the actual movie. I saw something about this within the past couple of weeks, but I don't even know the movie, guys. The Big Short. Okay, I get it. Ha ha. Ha. What are my plans for standard library? I literally just talked about that for 3 hours. If you missed it, you can go watch the VOD. More than 3 hours. What time is it? It's 1:30. It says 2:30. I have to subtract one. So we've been talking 3.5 hours. Yeah, that information is in there. Okay, I think the Discord part is done, so I'm going to close Discord. Thanks, everybody. If Discord people are still here, thanks for coming by. It's been fun. We'll probably modify the format, like I said, a little bit, or vary the format so we could have different kinds of discussions. I think that would be good. Time to fix my clock. I know, I don't know how to fix it except maybe to reboot, and I don't even know if that'll fix it, so why would I reboot? When I can just subtract an hour mentally every time I look at the clock. All right, and thanks everybody else. I guess it's time to sign off. Thanks everybody for coming by. Yeah, we'll do some version of this sometime in the future as well. I don't know how they're going to go. I don't know what the format's going to be. Like, I feel like since this was the first one, we sort of front loaded a lot of kind of questions, and next time would naturally be different, even if we did the same thing. We'll just find out.